Good evening to everyone and welcome to this channel of excellence. This is GMAETS 41. So in this live class section, I want to give the final address in preparation for the Physics 101 exam that is kicking off tomorrow, being the 6th or 7th, I guess, tomorrow being the 7th of March 2026. So there are some of our friends that will be taking this examination tomorrow. Already you are aware that I've actually provided you with the playlist for your exam revision, for which there are two key videos covering some aspect of this examination revision. I want to believe that by now you've covered these two videos with arrow pointing at them. UNIZIC Physics 101 Complete Examination Revision Part 1, and of course Part 2. So if you have done justice to that, and also if you've actually followed up with some other video lessons I provided, like that on dimensional analysis, all right, and then the video lesson on motion, then of course you are good to go. Very well set to go in there and blast the examination tomorrow. Information reaching me is the fact that you students have been told not to come. You've been told not to come with calculator, so calculator is not allowed. And this I've actually talked about time and again, advising students. They say when you hear of CBT examination, most times you are not allowed to use calculator. This information, as long as I am concerned, is a bad one. Yes, it's a bad one. It's not good at this moment. But again, to the course reps of the 100 level students in UNIZIC, discuss with the course reps so that they can also discuss with the coordinators of the courses about this issue of not using calculator or using calculator. Because sometimes it has been observed when these rules are given, where we find ourselves in this part of the world, exam questions may be given, and then it would not respect the fact that students are not allowed to use calculator. But I hope that they will do the right thing anyway. So quickly, I want to draw your attention to some other important things, which I know very well that your exam questions will also come from this part. I just want to point them out for you. Already in this revision class, which I've posted the link before, I want to believe that you dear students, the ones that are serious, that's the truth, okay, have done justice to them. So I want to quickly draw your attention to your workbook. I want to quickly draw your attention to your workbook. And then as a loving warning, to discourage those of you using AI or whatever to solve for questions, it's very wrong to do that at this point in time. Your exam questions, I want to tell you, they are with you in the comfort of your home right now, and their answers are with you as long as you are fully connected to GMAETS 41. So I want to quickly draw your attention to the last part of what I consider the exam revision of Phys 101, Part 3, because Part 1 and 2 were already available for you. I made them available since, I think, early this week. In this part 3, I'll be drawing your attention to your workbook. I've actually solved these workbooks, but I want to point to some key questions that are clear exam questions. You know that you guys are taking this exam in batch, right? So definitely, you will see these questions. Different batches. Your workbook, the way it was constructed this time around, your exam questions, you have them there as well too. Yeah. You have them there. So without wasting time, I would like us to move straight to your workbook. I want to believe that you have your workbook there. I'll be pointing to some of these questions and then, of course, showing you their solutions. Showing you their solutions directly. If you have any question, you are free to, of course, leave your comment, you type your question, and if the time is there, I'll respond. Okay? If the time is there, I'll respond. So quickly, let us go straight to your workbook. Chapter 1 of your workbook is based on, please don't mind, this is our GMAETS 41's learning community. So we have just our students there, those registered with GMAETS 41. Okay, I want to share with you some things that they have direct access to. Your workbook solution. Okay, your workbook solution, you have key exam questions there. So I want to direct you there. From your chapter 1, where you dealt with the concept of quantities and their units, just get the whole idea of quantities and their units. Get the whole idea of quantities and their what? Units. Get the whole idea of dimensional analysis. But if you come to that dimensional analysis, why you get to remember the dimension of different quantities. Okay, very important. Dimension of power, dimension of momentum, dimension of force, dimension of acceleration, work and energy, they have the same dimension. Momentum, I want to believe that by now, for the past 4 months, it's sufficient for you to have been very good with those aspects. Look at question number 1 under that chapter 1. Question 1, chapter 1. An object covers a distance x in a time t, and okay, as indicated in the equation below, x equal to at plus btq. I actually released a video lesson on that on YouTube. Okay, so please, you can go through the playlist section of your workbook, because I have a special playlist created for Physics 101, Chem 101, Math 101. Are you following, right? If you go to that playlist, you will see the question there. You see the question. I want to believe that you friends already have the question. You are supposed to have the questions with you. You're supposed to have the questions already with you from your workbook before you submitted it. But if you don't have it, you can go through the playlist of your workbook on this channel now. As I'm telling you this, make sure you follow my instructions strictly. I've told you 2 video lessons that I turned your exam revision part 1, part 2. A lot of your exam revisions, exam questions are there. Their answers clearly analyzed. And then I'm pointing you, I'm drawing your attention to your workbooks now, right? To your workbook. Question 1 of that your chapter 1 is a key exam question where you were given this equation, x equal to at plus btq. And you were asked to find the dimension of a and b. In solving that question, it leads to simultaneous equation, just one simple simultaneous equation like that. Give attention to that question. Some of you would see that question in your exam. And like I've said, don't be deceived by AI. AI can't help you tonight. Please run away from your AI. Your exam questions, your school has revealed it to you. The point now is that some of you are not aware of this, and you may just not know exactly the core areas that your exam questions are coming from. I'm pointing this to you now. So take note. I've covered some of them in those video lessons, and then your workbook. So question 1 of your chapter 1. If you don't know how to solve that question right now, make sure at the end of this revision, you go and learn how to solve it under dimensional analysis. You're given x equal to at plus btq. X is distance, t is time. And then you're asked to find the dimension of a and b. Okay? I think the dimension of b was lt raised by minus 3, and then dimension of a is either lt raised by minus 1. Yeah. You see, I'm screencasting. Sorry that the solution to that question, chapter 1, I actually did not provide a note on it. Go to on this channel via the playlist. You see that, like I said. Okay, let us move on. Question number 2. Yeah, question number 2 is not significantly an exam question. Now look at question number 3 in your chapter 1. Question number 3 in your chapter 1. That question that was given with respect to a guitar string, a guitar. Now the velocity of the guitar was given V equal to K L raised to power A, M raised to power B, T raised to power C. And then you were asked to find the value of A, B, C. Some of you will see that question tomorrow. Some of you will see that question tomorrow. Like I said, the solutions are already available on this channel. The video lesson where I solved questions, I think in the live section you will see that video, and then I actually moved it to the workbook playlist. By now, you all should have known how to use this channel 100%. Thanks to YouTube, YouTube have made it easy for you to easily search for information. So go and learn that solution. I think the values of ABC are half, minus half and half, something like that. Now how to solve it, go and learn it. It's very simple. It's 1 plus 1. You are given V to be equal to K, L raised to power A, M raised to power B, and capital T raised to power C. That T in the question was given as tension. T was given as what? Tension. So you need to substitute the dimension of velocity, which is LT raised to power minus 1. You already have your L, which is in dimension form, and then your capital M, which is in dimension form. Then that T is tension, and tension is force. So you substitute the dimension of tension, which of course is MLT raised to power minus 2. Then of course, do your simplification using your knowledge of indices. That question is a clear exam question. Some of you will see that question in your exam tomorrow. Prepare for it. Question number 4 in that chapter 1, it's not much of a problem. I'm not saying that as much of your exam question. So whether you revise it or not, that question number 4 rather, in your chapter 1 workbook, whether you revise it or not, I don't think there's going to be any challenge. So let us move on to chapter 2 of your workbook. Chapter 2 of your workbook. Please take note. I am not saying that your exam question will only come from the workbook or so. I had provided 2 full-time exam revision video lessons. I want to tell you that even last sets, they used that, and many of them confessed to that. I hold your examiners hands down in Unizik. Yes, they may not want to believe it because we live in a country where, people don't appreciate good things sometimes. That's the truth. But you friends are students. Leave your examiners to themselves and other things. If you spend your quality time on this channel tonight, you will go in there into your exam hall, hold your examiners to stand still, blast the exam, come out with A splashes, and of course, first class. I'm saying this with 100% assurance. Those 2 video lessons, you've covered them, that is a big plus for you and what I am showing you this night. Chapter 2 of your workbook, it covers vector. It covers what? Vectors. What are your likely exam questions as covered in that chapter 2 of the workbook? What are likely your exam questions? Right? So we have the very first question there that talked about pointing vector. The very first question that talks about what? Pointing vector. You were given the electromagnetic field vector E. And you were given you were given the electric field vector rather, E. And you were given the magnetic field vector H. Pointing vector is E cross H. That is the electric field cross the magnetic field. You see that question? It's a clear exam question. Some of you will see question on it in your exam hall tomorrow. Prepare for it. Now you were told that you are not allowed to use calculator. For me, I don't see anything on that. Even if I am not happy hearing it, I'm not happy on you people's behalf. Because many of you have neglected this instruction I've always given to you that you should train your brain without calculator. Most of all these questions you're going to meet in your exam hall tomorrow, they are solvable without calculator. As a matter of fact, calculator might even waste some of your time in it. I've talked about the knowledge of your multiplication. Very important to help you to be fast. So that's question number 6 in your chapter 2 under vectors. Exam question. Are you following right? We come from there. So why am I can't read this very well. Miracle. What did you say? Can you ask the question again? Can you ask the question again? Why am I what? I didn't see that question clearly, please. Let us move on. Let us move on. So give attention to question number 6 of your manual. Give attention to question number 6 of your manual. Let's move on. Question number 7 of your manual is not an exam question for you. So if you decide not even to look at that question at all, don't worry. That question number 7 that talks about, force, where F is equal to Q, open bracket, V cross B. Yeah. Meanwhile, question number 6 on pointing vector. Remember, that guy is a cross product. So you use the knowledge of your 3x3 square matrix to solve it. The solution of it is on this channel. That takes us to question number 8. Question number 8 is a crystal clear exam question. Some of you will see that question. You will see that solution as in that question in your exam. Question number 6. So give attention to it very well. I've actually solved it, like I said, for you guys. So give attention to it. Very, very important. Question number 6. Okay? And then that takes us to, is it question number 6 I mentioned, or question number 8? Question 8, page 7 of your workbook. Some of you will see question on it. So I don't know those of you that will see question of that question number 8. But you must see it. Question number 9 is a crystal clear exam question. Question number 9, still under vector. Some of you may see question on that. You are asked to calculate the work done by the force on the body. You are given the force vector, and you are also given the displacement vector. I know that work is a scalar quantity, because work is a scalar quantity. If you are given force vector and displacement vector to calculate work, you are going to do F dot D. That is the force vector dot the displacement vector. Are you following, right? I hope you guys can hear me. I hope you guys can hear me. Please, if you have a question, you type. Let me see. Then question number 10. Some of you also will see that question. Some of you will see that question. So why am I... Ugochukwu, you're trying to ask a question. I'm not seeing it well. I'm not seeing that question. Let me see if I can log in with this other device so that I can read out your question. But while I'm logging in, I think we can continue. The streaming. So under which topic? Or I'll be under which chapter? Okay. All right. Please, if you have a challenge and I am not able to see your question, you can send the question later. Okay. So under which topic? I am dealing with vector, as in vector now, in your workbook. In your workbook. Are you following? In your workbook. There are some questions I've pointed to that are crystal clear exam questions. Some of you will see it tomorrow. The question now is who will see it, since it's a batch by batch exam. So you want to prepare for them. Then question number 10 is also a crystal clear exam question. You are asked to find the angle between vector A and vector B. Okay, he said, why is he not seeing you? Okay, you're not seeing me. I am screencasting. I'm screencasting, so you can't see me standing fully. I have to really rest. I just needed to do this video, very important, as a final guide in the revision part 3 for you guys to point some of those things. I really can't go ahead solving these questions again since I've solved them for you people in your manual, as in the solution to the workbook. Okay, so I just want to make a review. I will show you the solution of the ones available, I think from chapter 3. As you can see from chapter 3, some of the questions are already available, solutions are showing. Don't worry, when we get there, you are going to see them. Please, vector, under vector, chapter 2 of your workbook. I've mentioned the questions that are clear exam questions. Okay, so you want to work on them. Let's move on to chapter 3. Chapter 3. Chapter 3, you have question number 11 there. There you are dealing with motion in one dimension. Motion in one dimension. Question number 11. I think I have the solution here. This is question number 14. Let's see. Question number 11. This is question number 11, right? No, this is question number 14. Good. This is question number 11. You can see the solution there. You can see the solution there. That question on velocity time graph. You want to give attention to it. It is a crystal clear exam question. So you can be given this and you're asked to calculate the total distance. Or you can be asked to calculate the time during the first phase of the journey. Because in this question, question number 11, chapter 3 now, you were given the uniform acceleration, you were given the velocity. During that first phase of the journey, where I labeled it as OAE. That first phase of the journey, OAE. That time of 0.16 was not given. That time of 0.16 was not given. If you look at the top of the diagram, Q11, you notice where I saw for T1. T1, which is 4/25, giving you that 0.16 seconds. Because we are given the acceleration and you are given the velocity attained at that time. So time is equal to velocity over acceleration. You calculate that time. So you have to give attention to that. This particular question, you can be asked to find the time during the first phase of the journey, and then you could be asked to find the total time. You could be asked to find the total time. Sorry, I mean the total distance, where you use the area under the curve, which is area of the trapezium. So you have it there. Solution to question number 11 is a crystal clear exam question. Then question number 12. Some of you will also encounter that question in your exam. Question 12, where you were asked, I'm in chapter 3 of your manual, now take note. A car accelerates uniformly from rest at the rate of 5 meters per square second. How far will the car travel in the 7th complete second? In the 7th complete second. I used 2 different approaches to solve this question and arrived at the same answer. This question is an equation of motion problem that follows second equation of motion. You can see that equation of motion, S equal to ut plus half at squared. S equal to ut plus half at squared. Now, we are told that the motion, that the object or whatever that is undergoing the motion, the car accelerates uniformly from rest. When something accelerates from rest, you know that the initial velocity is 0. And that is why u there is equal to what? 0. That's why u there is equal to 0. Are you following, right? So, if you substitute that u equal to 0 in that second equation of motion, you will notice that the ut part will disappear, so that the equation becomes s equal to half at squared. Now, you are asked to calculate Michael Simon, okay, he said, why is he not seeing me? But I hope other persons can see me, right? I hope other persons can see me and you can see the solution. The most important thing is for you paying attention to what I am saying, and then the solution I am showing you there. If you are being tested on calculation, which of course, your Physics 101 are more of calculation, because it's pure mechanics. It's Physics 102 next semester, you will see much of all these statement questions. This time around, you will see calculations a lot. Yeah. Okay. So, if you're asked to calculate the distance in the 7th complete second, whenever they give you time, you hear that time, where they quote the time like position. Where they quote the time like position. You can see in this case, 7th second, 5th second, 3rd second, 4th second. If you're using direct formula, you are meant to calculate for that particular time mentioned and the time before it. So you see, you have your s equal to half at squared. Substitute the parameters given to you in that s equal to half at squared. Solve for the time 7 seconds. Solve for the time 6 seconds, and then do the subtraction. I want to believe you friends have the question there with you. So at this point, you should have your manual, or you would have a kind of snapped the manual and whatever, I don't know. Should have done that. Should have done that. If you did not, then please take note. Next semester, don't repeat that mistake. If you get your manual, forget whatever they tell you. Don't snap it. Don't do this. Can't even photocopy it. You can't photocopy it. Forget all those things. You know, Nigeria, we have our own problem ourselves. We have our problem ourselves. I heard this thing that some of you were told not to photocopy or what. You should have a copy of that thing because it should form part of your revision. Okay? But who am I to challenge whatever decision they are taking, or those nonsense things they say sometimes? Please, let's continue. Let's continue. The next thing we are looking at, I think we're already in chapter 3, dealing with motion. We're already in chapter 3, dealing with motion in one dimension. I'm highlighting. Now, there was this alternative method I used in solving this particular question as well too. I used the formula half times the acceleration given times 2 times n. That n there is the 7-second mentioned, minus 1. If you use the formula, you can solve directly and get the answer. You wouldn't need to go through solving for S7 and X6. Are you following, right? If you do that, if you can remember the formula, use it directly, that is cool. Let us move on, please. Question number 13, page 10 of your manual, under chapter 3. Question 13 of your manual. Some of you will encounter that question. It's a real-time exam question. Are you following, right? Some of you encounter it. And solving the question is very simple. The position vector of an object undergoing uniform acceleration is expressed according to the equation. And the equation given was x equal to 3t plus 8t squared. I think I actually released a special video lesson covering that. It is still there in the workbook section, the workbook playlist on this channel. You can check it out. Are you following, right? Yeah, where I solved that. Very simple. So x is equal to 3t plus 8t squared, and you were asked to calculate the instantaneous velocity at t equal to 4 seconds. At t, you know, you were specific about the time, so you substitute the time directly. But this is what you do. To calculate instantaneous velocity, of course, you have to differentiate that position given x. X which is equal to 3t plus 8t squared. Differentiate with respect to time. You will get 3 plus, I think, 16t if you differentiate. Then once you do that differentiation to get dx dt, which is 3 plus 16t, like I said, fix that time, which is 4 seconds, and then you solve. Are you following, right? And then you solve. So that is how simple you do that. That's how simple you do that. All the solutions are available for you, like I said. Okay, make use of them. I'm only trying to, I think this, you can see solution to number 13 now. Yeah, look at it. I think I have it here. Look at it. So you're given x equal to 3t plus 8t squared in meter. Then at time equal to 4 seconds, you are required to calculate the instantaneous velocity. If you do that, you'll be getting 67 meters per second. Differentiate and substitute the given time. So that's how simple it is. Let me be clear about something. See, your exam questions are going to be 1 plus 1. It has always been that way. Please. The only thing that will deal with some of you in the exam hall that tomorrow is lack of confidence. And some of you having a ready-made answer, cramming some unnecessary things. Take note that this thing I am telling you, that these are real-time exam questions. Your examiners may decide to just change a value. So don't just cram things unnecessarily. Understand how they are being solved. On this channel, I have done powerful work on these by the special grace of our God and helper that continues to give GMAETS 41 the strength to provide all these things for you. Understand them so that if they change number, you wouldn't be thrown away. You can just solve it and you drop the answer, right there. Question number 14, let's move on. Page 11 of your workbook. Question 14, that velocity time graph problem, that particular velocity time graph problem can never come out. It can never come out. As a matter of fact, that particular question in your manual is technically wrong. It can never come out. Don't even bother yourself about that question number 14. Don't. Mind you, anything I'm telling you now, I'm saying it with 100% assurance. Take note of that. You will come back with a testimony to even tell me that some of these questions were lifted directly, except if the examiners change the question overnight. But they can't do that. Even if they change it, they don't have any question to ask. That's the truth. Yes, in your phase 101, even if they change, they don't have question to ask. They can't teach you A and give you B. It's not done. If anybody is deceiving you that the exam question is going to be tough, they are going to do this or that, it's a lie. It's a lie. You see all the worked examples, all the examples that were solved in your textbook, if you have the textbook. You see your manual. Are you following, right? Your exam questions, they are there. And the 2 video lessons I released on exam focus revision, Physics 101 for Unit 6, Part 1 and Part 2, they covered this thing already. The part I am touching in this final revision are the part I did not touch because I actually focused on what supposedly students could feel are tougher aspects of Physics 101. I focused on them in that video lesson. These ones now on motion, which I did not touch because I told students they can, take video lessons on that. This part of motion, they are straightforward. Vectors, dimensional analysis, quantities and their unit, they are straightforward. So I want to touch this vector part, pointing out key areas you want to give attention to and some real-time exam questions that will be lifted from your manual. So let us move on, please. Question 14, forget about it. Question 15 is an exam question. Yeah, but that particular question, I'll give it 50-50. You may not. Yeah. Because that concept of the balloon, that question 15, a hot air balloon moving upwards. A hot air balloon moving upwards with a steady velocity of 10 meters per second at a height of 35 meters above the ground suddenly has an object dropped from it. The object is now dropped from it, but the balloon is going up, according to the question. Is going up and then they dropped an object. So you see that there is a kind of opposing motion. Something is going up, another thing was dropped from that thing. That is why in solving that question number 15, let me bring it out. That is why in solving that question, like I said, this question 14, forget it. If you even go through the solution, you will see where I mentioned certain reason why that question itself is even wrong. So what is the unit? What is the unit of what? I didn't get the question. I didn't get the question. Can you repeat the question again? So let us move on to question number 15. Look at it. So one technicality in that question is that the height, which is 35 meters according to the question, right? The height, which is 35 meters, from which the object was dropped. If you are substituting it into the second equation of motion, that height will be negative. The reason is because something was going up and then an object was now dropped from it. So there is this kind of opposing, are you following, right, direction. That is why the height will be a minus. Now, if they are giving you this particular question, say you see it, the quadratic equation you are going to get, like in this case, minus 37 equal to 10t minus 5t squared. The quadratic equation must be factorizable, especially so as I heard that you are told not to come with calculator. You were told not to come with calculator. So that question must, I repeat, must be factorizable. It's not something that will be solved using quadratic formula, almighty formula as you have there. Are you following, right? So take note of that. Now we are moving on. Question number 16 is a real-time exam question. Some of you will encounter that question. Are you following, right? Question number 16. Some of you will encounter it. So you want to make sure you go through that question number 16. Still dealing with chapter 3, right? I think question number 16 now is, still chapter 3. A ball is thrown vertically upward with a velocity of 4 meters per second. A ball was thrown vertically upward with a velocity of 4 meters per second. When you are throwing something up, the velocity with which it's going up is initial velocity. Are you following, right? It's initial velocity. When you release something, it's coming down. The velocity with which it is coming down is final velocity. So take note of this. At maximum height, for an object going up, the final velocity is 0. Are you following? Then at maximum height, for an object coming down, the initial velocity is 0. So all these concepts, you want to be aware of it. Now this question number 16 is a real-time exam question. Some of you will encounter it. You can see the solution there. So the initial velocity of the object was given, which is 4 meters per second. Now you are asked to calculate the maximum height attained. At maximum height, final velocity is 0. So the equation to use will be u squared over what? 2g. You can say that there. And that equation is still the equation of maximum height under projectile. I can't see the question 16. I can't see the question 16. You can only see the solution. In what we are doing here, you can only see the solution. I'm trying to dictate the question. But sometimes I don't dictate, or I'm not dictating all of them because I assume that you people should have the question already. If you made the mistake not to keep a copy of those questions with you, please next semester don't repeat that mistake. Once you get your manual, if it is to photocopy it, nothing would happen. Okay, you are not seeing the solution I'm talking about. All right. Look at the solution. Let me make it a bit bold. This is it, question 16. Question 16. So you are using the formula u squared over 2g. You are using the formula u squared over 2g. At maximum height, h is equal to u squared over 2g. Is that okay? Now remember that the object was thrown vertically upward. If maybe the formula you remember in the exam hall is formula of maximum height, because when they say calculate the maximum height, I know very well that almost all of the students, the formula that might come to your mind is maximum height formula under projectile. U square sine squared theta divided by 2g. If that formula comes to your mind, don't get confused. There is no theta given to us, no angle. The reason is because the object was projected vertically up. If you project an object vertically up, the angle theta is 90. It's 90 degrees. So that sine squared theta will be sine 90 all raised to power 2. Sine 90 is 1. 1 square will give you 1. 1 times the u square will not maintain the u square only. That is why the formula you are seeing here is simply u square over 2g to get your maximum height. Okay, let's move on. Like I said, that is a crystal clear exam question. Some of you will meet it if they are testing you on motion problem. Of course, they must test many of you on motion. Let's move on to chapter 4, please. Motion in 2 dimensions. This is now properly talking about projectile, because projectile is motion in 2 dimensions. Are you following? Now, definition of projectile, you are expected to know it. The examples of projectile, you are expected to know it. Projectile is a motion along a parabolic path. Projectile is defined as motion along a parabolic path. It's a 2-dimensional motion problem, because for you to talk about projectile, you have vertical axis and horizontal axis, and then the motion will be between the vertical and the horizontal. But the motion will call something like this. The path, the trajectory of a projectile is a parabola. If you fire a projectile, the road it follows, the path, the trajectory, road, path, trajectory, they are the same, but nobody is going to use the word road for you. It is either you hear the path of a projectile or the trajectory of a projectile is dash, and the answer is parabola. The answer is parabola. Now, examples of projectile, you expect to know them. Stone is an example of a projectile. Bullet is an example of a projectile. Ball, when kicked, is an example of projectile. So that is it. Necessary formulas under projectile. By now, you guys are expected to have known all of them. On this channel, I've covered works on projectile. There are 3 key formulas under projectile you are expected to know. Are you following? The formula for time of flight. When you hear of time of flight, it is the time taken for a projectile. Madu, Calista, I think you've seen the solution. I've already shown the solution to question number 16. I've shown the solution to question number 16 already. We are talking about question number 17 in chapter 4. Let's be faster. We'll round off all this motion concept, okay? After motion concept, we'll now look at one part of momentum. One part of momentum, yeah. Under collision, when you talk about coefficient of restitution, this is the first time ever, the first time ever since 2010, that UNIZIC is bringing in the concept of coefficient of restitution under momentum collision. And I'm pretty sure, I'm certain that you will be tested on calculation of coefficient of restitution tomorrow. So let us do and move on to that part. After that, we'll look at the concept of center of mass. Are you following, right? Center of mass. Yeah, there are several questions on it in your workbook. So question number 17, you can see the solution. Okay, but let me read that question. A bullet is fired horizontally with a velocity of 40 meters per second from the top of a building 50 meters high. How far from the foot of the building will the bullet be assured to touch the ground? So it's as if you have a building here. Are you following, right? You have a building here, and then from the top, a bullet was fired horizontally. You know, if the bullet moves this way, the next thing it will start curving. Parabola, projectile, to start curving to get down. It cannot move like this forever. So you are asked, how far? That is the distance. How far from the foot of the building will the projectile be assured to hit the ground? You know that this problem is a range problem. Is a range problem because under projectile, range is defined as the horizontal distance from the point of projection to the point where the projectile hits the projection plane again. Are you following, right? So what do you do here? The formula for range actually is R equal to think U square sine 2 theta. U square sine 2 theta divided by G. That's the formula for range. But you see, this particular problem, you don't need theta. You don't need theta. Yes, and that's why it was not given. The projectile was fired horizontally. So you'll be using normal equations of motion under gravity to analyze your work. But take note that range is distance, and distance is simply velocity times time. Forget the fact that range is given as U squared sine 2 theta over G under projectile. That formula, in fact, in the video lesson where I taught projectile, I derived it. That formula that range is equal to U squared sine 2 theta over G was actually obtained from U times T. And that is why in the solution here, you could see I have my horizontal velocity, which is the horizontal initial velocity they're given as 40 meters per second. And then the height from which it was projected is 50 meters. Your range will be equal to velocity times time, which is simply distance. You can see it as I wrote, a range is equal to unknown. But that range is your distance. That range is your what? Distance. So your distance is equal to ut. Since speed is distance over time, if you cross multiply, your distance is speed times time. Substitute and you get your value. But you know we need time here and we don't know time. So what do? You are going to use equation of motion to calculate time. Equation of motion under gravity. Second equation of motion to be precise, because we are given height. So using that second equation of motion, h is equal to ut plus half gt squared. Remember that the object is coming down, so g will be positive there. U is already equal to 0 under that consideration. The ux you are seeing there is the horizontal velocity, not the vertical velocity when the object is coming down. The vertical velocity uy when the object is coming down is 0. I've told you from maximum height, if you release an object is coming down, it is 0. So uy is 0. When you're talking about height is purely vertical. So the velocity you use there in the second equation of motion for height equal to ut plus half gt squared. That u there is uy. And the vertical velocity uy is 0 in that case, because if you release an object and the object is coming down vertically, the initial velocity is 0. So don't confuse uy with the ux that I used here. Ux is the initial horizontal velocity of that bullet, which was given as 40 meters per second. That is what you use to calculate the range, because the range is also horizontal distance. So the reason I used h equal to ut, h equal to half gt squared. The ut part will be 0 because u there in that second equation of motion under gravity, that u is uy. That one is clearly 0. So that the h equal to ut plus half gt square will now reduce to h equal to half gt square, as you are seeing, solved there. Now, why am I actually using this formula? It is to calculate time, because you need time to substitute in that s equal to uxt. You can see the calculation there. The time is 3.16 seconds. So take that time, which is 3.16 seconds now, into the s equal to ux times t formula, which gives you the horizontal distance that the bullet will cover. And of course, you have it 40 times 3.16, and that gave us 126.4 meter. Please let us move on. Question 17 is a crystal clear exam question. Question 18 now, I think we spent time on that question 17 a lot. Question 18 is also a crystal clear exam question under projectile. A tennis ball is thrown at an angle of 30 degrees to the horizontal with a velocity of 50 meters per second. You are asked to calculate the maximum height reached. You are also asked to calculate the time taken to reach the maximum height. Now, in this projectile problem, you were given theta value, and you are asked to calculate the maximum height. So you're simply using the formula square of u sine square theta divided by 2g. That is the formula for calculating maximum height attained by a projectile. All the parameters you need in to solve this problem. This question number 18, all the parameters you need to solve it, they are there. You can see it clearly. Theta is given, u is given, so substitute there and then solve. It is said that you're not going to use calculator. It is said that you are not going to use calculator. I just received the information this evening. Although I have been warning students about imagine now that you are given this question tomorrow, and where we have 98% guarantee that this question will appear for some of you tomorrow. 98% assurance. I taught the concept of special angles. Special angles. Because if your examiners are to test you guys in areas that involve angle, where you have to evaluate sine, cos, and tan of anything. The fact that they said you are not allowed to use calculator, the examiners themselves do not have that right. I repeat, the examiners themselves do not have that right to give you questions where the angle is not a special angle. As a matter of fact, I want to say this. It's not as if it's anything to raise tension or whatever. If you are given any angle that is not a special angle, you students can decide not to take that exam tomorrow. Call for cancellation of the paper. Call for it. It has happened in Unizik before. Last two settings start 202, second semester. It's after that time I started advising students to discuss with their course reps, so that course reps will meet together and go and meet course coordinators. Discuss with course coordinators, because you see, some of them will just wake up and give you questions that require you using calculator, whereas you will be the one seated in your library tomorrow, digital library, taking an exam with invigilators. The invigilators on their own may not know whether you guys really need calculator in this particular question or not. Their own is to enforce the rule that has been given. That is why there are things as students, especially the course reps, there are works people are meant to do, serious works, on behalf of your colleagues, your mates, your mates, yeah, on behalf of the of your colleagues. It's not all about making sure that they buy workbook, or making sure that they pay 1 or 2 money for submission of assignment or anything, because of course some of you guys do it. Help yourselves. Help yourselves. If you fail a course, nobody is interested in you. Take notes. Nobody cares about you. Take notes. It is you and you on your own. So if you're a course rep, you're a student, please, after now, you still have something like Chem 101. Although Chem 101, no real calculation stuff there. No real calculation stuff. But you still have calculation there. Discuss with the course coordinators. But then on your own, make sure you are working to learn how to handle things without calculator. Please, very important. On my channel here, I teach a lot and I advise students to try to be independent of calculator. So please try to learn about special angles tonight. On this channel, you have it in the live section. I have special video lesson dedicated to how to evaluate sine, cos, and tan of special angles, which includes 0 degrees, 30 degrees, 45 degrees, 90 degrees, 60 degrees, and 90 degrees. And it continues into the second quadrant, 120 degrees, 135 degrees, 150 degrees, 180 degrees. It continues to the third quadrant in that order. Anyway, I'll leave that to you people. At this time, it's a bit late to raise such awareness, you know. But your course rep still has the right to coordinate even that tomorrow. Yes, even that tomorrow. And ensure that a call is given to the course coordinator in case there are parameters given that requires you using calculator. Besides, we are not taught on how to be independent of calculators. So I wonder why they would tell you not to use it. But for me, I don't advise it anyway. I work without calculator a lot. Okay, so the maximum height formula is there directly, so you apply it. The second part of the question, you were asked to calculate the time taken to reach the maximum height. You know, this exam is CBT, so no theory. It means you can't see a question where they will tell you calculate this or calculate that. Except if they ask, what is the maximum height and the time taken to reach the maximum height respectively? Then options may come whereby, like in this case, maximum height is 31.25 meter, then comma, the time to reach maximum height is 2.5. So you may have it as 31.25 meter, comma, 2.5 seconds. So they can combine the two quantities they want you to calculate at once. It's possible. Now, time to reach maximum height is not the same. Is not the same as time of flight. Please take note. If this is the projection plane, so you have your vertical this way, right? Maybe something like this. And your projectile motion goes from here this way. Your time of flight is the time taken to launch the projectile from here to the maximum height and then to come down to the projection plane itself. So time of flight, capital letter T, is the time taken to reach maximum height and to come down from maximum height. That one is different from time taken to reach maximum height or time taken to come down from maximum height. In fact, time of flight is 2 times this particular time they are asking you to find here, the time taken to reach maximum height. That time taken to reach maximum height is simply u sine theta over g. Time that it takes a projectile to reach maximum height or to come down from maximum height is u sine theta over g. You can see it showing on the screen. But if it is time of flight that you're asked to calculate, it's going to be 2u. It is going to be 2u. 2u sine theta over g. So take note of that. We move on to question number 19. Question number 19 is also a real-time exam question. That question number 19 is a real-time exam question. Let's see, where is question number 19? Where are we? Good. This is question number 19 solution. That's question number 19 solution. The question, a 2 kilogram stone is whirled, that is turned in a horizontal circle of radius 1.20 meter. If the tension in the string is 16 Newton, find the period, capital T, of rotation. So you notice that mass is given to us, radius of the circular part was given to us, and of course, tension. Tension here is force. You can see the unit of the value, 16 Newton. You are asked to find period, capital T. You know, you hear about period, you hear about frequency under circular motion. In this particular problem, since they gave you mass, and they gave you radius, they gave you force, which is tension, and you are asked to find period, the first thing you have to do is to use your centripetal force formula. Use your centripetal force formula. Are you following right? To calculate velocity. To calculate what I said, velocity. use your centripetal force formula to calculate your velocity. Look at that formula on the board where I wrote but V equal to square root FR over N. That formula is from centripetal force. Remember that centripetal force is F equal to mv square divided by R. Centripetal force is F equal to mass times square of velocity over radius. So from that formula, if you make velocity subject to a formula, you will get square root the tension, which is the force, times radius divided by mass. If you substitute, you get velocity to be 6 meters per second. Then from there, you can now use the period formula. You know, most of us know that period is 1 over frequency. But here we don't have frequency. So you can't use the 1 over frequency formula directly. But hey, that relationship 1 over frequency can still be expanded on. And you get this formula here. But let me tell you one quick trick. Velocity or speed. Speed is distance over time. Speed is distance over time, which means that time is distance over what? Speed. Look at that formula where I wrote capital T, which is the period, equal to 2 pi r over v. This is what you should remember. That 2 pi r is the circumference of a circle. 2 pi r is the distance around a circle. That's what 2 pi r is. So time is simply distance around that circular part that the stone was being turned around. Are you following, right? Circumference of a circle is distance around a circle, which is 2 pi r. So if you are using that idea, time is equal to the distance around that circle, because that's the distance that is being covered by the stone, divided by the velocity. And the distance around the circle, like I said, is 2 pi r, then over v. So that is how you came about that formula there. Although that formula can also be obtained directly from angular frequency or angular velocity formula, omega equal to 2 pi f, and that f is 1 over t. So omega, which is w, is 2 pi over capital T. And we know that omega alone is equal to velocity divided by r. So if you remove that omega, which is equal to 2 pi over capital T, period, remove the omega, fix velocity over radius. If you are doing that now, make v subject to the formula, you will notice that you get this formula that I'm showing on the screen there, which of course is the formula for calculating the period in this case. If you do that, you get the value as 1.26. You get the value as 1.26 seconds. That's the period. Please let us move on. I am done with question number 19. We are moving on to question number 20. All right, question number 20. Question number 20 is a related exam question per se as well too. Yeah, it's a related exam question, but this is one thing you want to know about that question number 20. Let me read it out. A turntable of radius. You can be looking at the parameters displayed on the screen, because those are the values, you know, given the question. A turntable of radius, small r, equal to 0.75 meter, spins so that a point on its ring has speed v equal to 3.60 meter per second, and angular speed is increasing at alpha is angular acceleration, equal to 0.8 radian per square second. The unit of angular acceleration is rad per second, that is radian per second. Find the magnitude of the resultant acceleration. Now, the first thing you want to take note of is this. If an object is undergoing circular motion, we have two types of circular motion: uniform circular motion and non-uniform circular motion. If you are asked to calculate the resultant, the word resultant acceleration comes in when you are asked to calculate, you know, something that involves two acceleration. In this case, you are asked to find the resultant acceleration. So there are two accelerations that will make it up. It means that this motion is actually non-uniform circular motion. That is why you were asked to calculate the resultant acceleration. Under circular motion video lesson, I highlighted this very well. I dealt with it, explaining it crystal clear. Resultant acceleration comes in as a result of non-uniform circular motion. In uniform circular motion, you don't have anything like resultant acceleration. What you have there is centripetal acceleration. Under uniform circular motion, what you have there is what? Centripetal acceleration, which is square of velocity divided by radius. You can see the formula there. A subscript C, centripetal. But if you go to non-uniform circular motion, there will be an added acceleration called tangential acceleration. Under non-uniform circular motion, we have a second, another acceleration, which now adds up to our centripetal acceleration. We have another acceleration called tangential acceleration. And based on the values given to us in the question, tangential acceleration is radius times angular acceleration. That tangential acceleration is acceleration along a straight line. Acceleration along a straight line. If an object is moving along a circular path, and let us assume that maybe you tie the rope to the object and you're now spinning the object, you're whirling it around like this. If the object cuts, it will move along a straight line. The velocity it has as it is moving along that straight line is called tangential velocity. And the acceleration it has under that condition is also called tangential acceleration. So there is a relationship between tangential acceleration and angular acceleration. Just like there is this relationship between tangential velocity, also called linear velocity, and angular velocity. These things, they are corollary. Under rotational dynamics, I already highlighted the similarities between translational motion and rotational dynamics or circular motion. We know that V, which is straight line velocity, called tangential velocity or linear velocity, V, is equal to RW. R there is the radial position times W, which is omega, angular velocity. So linear velocity and angular velocity are related through radius, such that linear velocity is equal to radius times angular velocity. In the same way, there is a relationship between tangential acceleration, which is linear straight line acceleration, and angular acceleration alpha. That is the relationship you are seeing displayed on the screen there. Tangential acceleration is equal to radius times angular acceleration. I'm trying to explain this concept so that you understand it very, very well. Are you following right? Please, is there a question here? Is there a question? Let's see. Please, can you pose the question now? Can you pose the question you just asked if you have a question? I think I've found a way to see your message clearly. I found a way to see your message clearly using this vertical screencasting. If you ask a question now, you can see it clearly. Please, let's continue. Back to our resultant velocity, resultant acceleration that you were asked to calculate. The resultant acceleration is obtained from Pythagoras theorem. It is simple. It is equal to the square root of centripetal acceleration raised to power 2 plus tangential acceleration raised to power 2. Now, our tangential acceleration is the radius times angular acceleration given in the question. Because in the question, angular acceleration was given to us, alpha. You can see the values shown on the screen. Then, centripetal acceleration is calculated from the square of tangential velocity divided by radius. So once you get your centripetal acceleration and get your tangential acceleration, square each of them, add them, and take the square roots. You get resultant. Remember, whenever you hear resultant of a quantity, always think towards Pythagoras theorem. So after doing this, you get your acceleration to be 17.3 meters per square second. So this is a classical exam question. Some of you will see it in your exam. Take note. Let us move on to chapter 5. Gravitational field. I won't talk about gravitational field, so I will skip this chapter. I have a reason. In that part 1 of Physics 101 revision and part 2 of Physics 101 revision, I've already treated gravitational field completely. I think in part 2 to be precise, look at it, you can see that Unizik Physics 101 complete exam focus revision topic by topic part 1, and then Unizik Physics 101 revision complete exam focus revision topic by topic part 2. In that part 2, I think the part 2 contains complete analysis of gravitational field and equilibrium. So please, since early this week, or even I think late last week, I'd already released these 2 exam focus, video lessons, right? They were actually made for your revision, and you have classical works there. Those that have taken it already should be aware. Your dynamics, everything about dynamics, where you treat, Newton's equations of motion, and especially giving particular attention to Newton's second law of motion, where F is equal to ma, which is now applied. When you're talking about dynamics, you look at the concept of tension force, normal force, you look at the Atwood machine, the tightrope walker, you look at the case of pulley. They are all dealt with in those video lessons. So let us move on to what we are dealing with tonight. So I will skip this chapter. Take note. I will skip it, please. We don't have time to waste. Anyone that I've covered already in those video lessons, that exam revision on Phys 101 part 1 and 2, I won't talk about them here. So chapter 5, under gravitation, everything on it you need to know. They're already available. Are you following, right? They're already available, so you can actually reach out for that. There is this particular question where you might be asked, maybe calculate so-so quantity under gravitational field at a height of so-so value. In that case, the radius of the Earth, what you do is to add the height there. Imagine I ask you to calculate the escape velocity of maybe a rocket, which is projected from a height of 20 kilometers above the Earth's surface. Calculate the escape velocity of a rocket launched from a height of 20 kilometers above the Earth's surface. Look at this question number 22, where I calculated escape velocity. To solve that question, your escape velocity will be equal to square root of 2g, that r. You have to enclose it in brackets and then add the height given to you. So it's going to be square root 2g, open bracket, capital R, which is the radius of the Earth, plus h, the height given to you. So you want to take note of that. And when you are solving this, I think it is expected that your unit should be in meter per second. If the final option is given in kilometer, you can do the conversion by dividing the meter per second by 1000. So take note of this point that I have actually mentioned here. Let us continue. If you join this revision class, what I am pointing out to you, please make sure you share the link to this live class to your WhatsApp group, your departmental WhatsApp group, okay, so that your friends, your mates can join. Anyone who wants to be guided on questions in your manual that you want to give serious attention to. Don't play with these questions I am pointing to. Remember, this is batch by batch exam. Are you following? So you don't know particularly the question you'll be exposed to. You don't know. You don't know particularly the question you will be exposed to. Therefore, as I'm pointing all these questions, it's not all the questions that I'm telling you to give attention to, but many of them in your workbook, they're actually your exam question, plus the 2 revision videos I just showed you just now. Question number 23, you are asked to calculate gravitational potential. Yeah. Question number 22, right? 23. Calculate the gravitational potential at a point on the Earth's surface. The mass of the Earth was given to us. The radius of the Earth was given to us. Universal gravitational constant, capital G, was also given to us. That is also an exam question, but although that has been covered in the part 2 of the exam revision video, okay? Question number 24. Kepler's third law was applied there. Kepler's third law was applied there. Please, know the formula of Kepler's law. Know the statement of Kepler's third law. Know the statement of Kepler's third law. In part 2 of the revision, I've covered them very well. But of course, if you look at the equation on the board here, is it the equation on the screen? T squared is directly proportional to square of the radius. That is Kepler's third law of planetary motion. We have Kepler's first law, we have the second law, and we have the third law. Now, you can be given question on this question number 24. You can be given question on this question number 24. The only thing they won't do, the only thing your examiner will not do, is likely giving you values that will stress you to be talking about all these solar years and other things. Okay, they might give you direct question where you use the formula T squared over R cubed. That is T1 raised to power 2 over R1 raised to power 3 equal to T2 raised to power 2 over R2 raised to power 3. Can be given questions like that, right? But having said this, I must state clearly that this particular question, 90% assured, 90% assured, you won't see it in your exam. Yes, you won't see it. You won't see it. You won't see it. Take notes. Kinsley, for John, you're welcome. Kinsley, you're welcome. For John, you're welcome to join this live class. We are looking at your real-time exam question, added to the ones I covered in part 1 and part 2, because this is part 3 of your Physics 101 exam revision class and final guideline. I've already addressed you students from the beginning, telling you and assuring you that your Physics 101 exam question, they are very simple. 1 plus 1, that's the truth. If you've covered your manual very well and you've taken the 2 video lessons that I released for revision, they are not real teaching video lessons per se. They were actually meant with your exam revision in mind. So it's more of summary of topics, definition of terms, and then calculations, formulas and calculations. If you've covered that, part 1 and part 2, and then you're following up with this night final revision, you are 100% sure of your A splash. If you enter exam and you see question, you'll be smiling. Okay, for John Udochukwu, where will I see part 1? On this channel, okay? If you go to the home page, is it in the home page, or rather the playlist? If you go to the playlist or the course section of this channel, you will see the exam revision, playlist. I created a special exam revision playlist for it. It contains your Physics 101, which you are taking tomorrow, contains your Math 101, which you are taking, on Monday, and contains your Chem 101, which you are meant to take in days to come. So please, if you don't have access to the 2 video lessons, make sure you gain access to it tonight, please. Like I said, I am not joking. Please, your exam questions, their answers, they are all there. Plus this one I am showing you from your workbook. Let's continue, please. No time. Let's continue. I've told you everything about gravitational field has been dealt with in that part, in part 2 of the revision. Mind you, I was going to say something. Gravitational potential and gravitational potential energy, they are not the same thing. Look at the formula of gravitational potential. Gravitational potential is V equal to universal gravitational constant, capital G, times mass of the Earth divided by radius divided by radius of the earth. This is called gravitational potential, which is the work you do in bringing unit positive mass, that is bringing unit mass, the work you do in bringing unit mass from infinity to a point in a gravitational field. Let me assume that where you are is infinity. The distance from where I am to where you are is so long that we don't even know what the value of the distance is. Therefore, I will refer to your position as infinity. Now, the work I will do, let me assume you are mass now. You are mass. Of course, humans, we are masses, you know. So, the work I will do to bring you from that your position at infinity to where I am, assuming that I create a gravitational field here. That work I will do in bringing you, if I call you a unit mass, the work I will do in bringing you from there to this position is what we call gravitational potential. Gravitational potential energy is different. The formula of gravitational potential energy is G m1 m2 divided by R. So you take note of that. I've covered it in part 2 already, like I said, so please reach out for it. Let us move on to chapter 6. What are your exam questions in chapter 6? What are your exam questions in chapter 6? Let me move on to chapter 6 now. Let's see your exam questions in chapter 6. Now in chapter 6, we have question number 25 there. Question number 25 is real-time exam question. Some of you will see that question in your exam tomorrow to appear on your screen. So make sure you give attention to that question number 25. Make sure you give attention to it. You know, question number 24, I told you calculation on it is 50-50. But Kepler's law, the statement, first law of Kepler's first law of planetary motion, Kepler's second law of planetary motion, Kepler's third law of planetary motion, know their statement. You will learn it from the gravitational field revision part in part 2. Then know the formula, the relationship that Kepler's third law brought out. Because that formula is significant. It is obtained from T squared proportional to R cube is shown there. And then if you are writing the full formula, okay, let's see, I think I have a question here. Gravitational potential, I thought it has a minus. Yeah, the minus that is there is because you are doing work against the field. That minus, if you see it, go for it. But for calculation purpose, we don't use the minus. Are you following, right? For calculation purpose, we do not fix the minus. What is the implication of the minus? The minus is simply telling you that you are bringing a unit mass to a field, to a gravitational field. So you are doing work against the field. If I create a gravitational field here as a mass, I am a mass. So I can create a gravitational field because every mass creates gravitational field. So if you are bringing another mass from anywhere into the field, you are doing work against the field. So because work is done against the field, that's why we usually put that minus, having V to be equal to minus GME over R. For calculation purposes, you don't fix that minus. Take note of that, okay? So you are not wrong in talking about, I think there is minus. So in your exam question, if they ask which of the following is the formula of gravitational potential, and you see these two options, one of the options is minus GME over R, and another option is simply GME over R. Go for the one of minus. But when it comes for calculation, drop that minus. All right. So we are moving to question number 25. Newton's laws of motion. You are asked to take G as 9.8. The examiner can tell you to take it as 10 meters per square second as well. So that question number 25 is a real-time exam question. An astronaut's pack weighs 17.5 Newton when she is on Earth. But only 3.24 Newton when she is on the surface of another planet. You were asked to find the acceleration due to gravity on that planet. Then what is the mass of the pack on the planet? All right. I was trying to look at the last statement that Okafor made there. So I've seen it. Let's continue, please. Now, it's important for you to know that the higher you are going, the smaller acceleration due to gravity becomes. You would have been hearing that acceleration due to gravity is a constant, 9.8 meters per square second, 10 meters per square second, approximately. Please, that constant value is only on the Earth's surface. If you move away from the Earth's surface, as a matter of fact, as you're even moving higher out of the Earth's surface, the value of acceleration due to gravity will start reducing. In fact, that is why under gravitational field, we have this relationship. Small letter g, which is acceleration due to gravity, is equal to capital letter G times mass of the Earth divided by radius of the Earth, divided by radius of the Earth square. So acceleration due to gravity is inversely proportional to the square of radius of the Earth, or simply inversely proportional to the square of height. So if you're climbing, height is increasing, acceleration due to gravity will be reducing. That is why in different planets, the value of acceleration due to gravity is different. On the Earth's surface, it is 9.8. On the Earth's surface, it is what? 9.8. Good evening, sir. I am just joining. You're welcome to join us, okay? You're welcome to join us. Like I said, the revision videos have been made available for you. There are 2 exam-focused revision videos that covers core aspects of physics, part 1 and part 2. In the exam revision section, the playlist, there's a playlist on this channel. If you go to the GMAETS 41's playlist, scroll gradually, you would see, or you go to the course section, I guess so, one of these sections, you will see the playlist covering the exam revision, okay? Then this one now is the last part of the revision, part 3, where I have decided to focus on your manual and then pinpoint your real-time exam questions. You people will see them in your exam hall tomorrow. You know, all of you will not see the same question. But the problem now is that which one would you see? You don't know. That's why I'm pointing those areas it should focus on. So back to this question number 25. When you see this question, the formula to use is just simple. You see, the mass of any object in any planet remains the same. Mass of any object in any planet remains the same. So mass is constant. Mass does not change. The quantity of matter in something does not change. What changes is weight. And weight changes with respect to acceleration due to gravity. Because like I said, in different planets, acceleration due to gravity is different. So if weight is equal to mg, what controls weight? The reason why weight changes is because acceleration due to gravity changes as well too, depending on where you find yourself. Mass is constant. So because mass is constant, we can make mass subject to the formula and we'll get weight divided by g. Because weight over g is equal to mass and mass is constant, that can give you room to formulate a direct proportional formula for weight over acceleration due to gravity, as you can see solved on the screen. Look at the formula I used. Weight on Earth over acceleration due to gravity on the Earth. I used W subscript E over small letter g subscript E. Will now be equal to weight in any other planet divided by acceleration due to gravity in that planet. So with that, you can make acceleration due to gravity on that planet subject to a formula, and then you solve. That is how you handle it. So don't stress yourself. Simply W1 over G1 equal to W2 over G2, just like you do in Charles' law. V1 over T1 equal to V2 over T2. So that's the formula that solves this guy. Weight on the Earth's surface over acceleration due to gravity on the Earth's surface equal to weight on that other planet over acceleration due to gravity on the other planet. So you now calculate acceleration due to gravity on that planet, and with that value of acceleration due to gravity on the planet, you can actually move ahead and find the mass of the object. But like I said, the mass of the object remains the same wherever the astronaut goes. So that is how you solve this question. Let us move on to the next question. I think the next one, question number 26. You can see the work there, very simple and straightforward question that you have there. Question 26. Give serious attention to it. It's a real-time exam question. It's a real-time exam question. You see that question number 26. People will see it. You will see it. Yeah, they have asked questions on this particular concept severally. So you see that question number 26, don't joke with it. Don't joke with it. Two forces acting on a body have magnitude of 20 Newton and 35 Newton, and directions that differ by 80 that differs by what? 80 degrees. The resultant acceleration has a magnitude of 20 meters per square second. What is the mass of the body? Here you are using your Newton's second law of motion purely. F is equal to ma. So the mass of the body is going to be F over A. Now you take note, your examiner could have given you the mass of the body and asked you to find acceleration under this condition. So if they want to switch this question for you, they might give you the value of the mass. You know, in your workbook, after solving for the mass, the result, the value was given, as in the value we obtained was 2.2 kilograms. So you can be given that mass of the object and they now ask you to find the acceleration instead. All you have to do is to resolve the force. Resolve the force and get the resultant force. You can see the direct formula I used there. I've explained that formula time and again. Summation of all forces along the vertical axis is each of the force times the angle times sine of the angle that the force made, measured from the positive x-axis. Do it for all the forces you have. Now you were told that the angle between these two forces is 80 degrees. So one of the simple approach you can use is one of the force should be lying horizontally, take it at 0 degree, then the other force you measure from that 0 degree, place it anywhere between the first quadrant. You can see the way I sketched the diagram here. 20 Newton and 35 Newton, then between them 80 degrees. Then apply your F sin theta and F cos theta. F sin theta analysis will give you the total force along the vertical. Then F cos theta will give you the total force along the horizontal. You've gotten two perpendicular forces. Apply Pythagoras theorem to get the resultant force. You can see how I analyze it on the board. If you apply Pythagoras theorem, you get the resultant force. Then apply your Newton's second law of motion. So that is how I solved that question there. Take notes. So your challenge is how to get the resultant force first. Like I told you, resultant force always, you go through Pythagoras theorem. Next question. The next question is given to us. We have question number 27. Question 27. A freight train has a mass of 1.5 times 10 raised to the power 7 kilogram. If the locomotive can exert a force, a constant pull of 7.5 times 10 raised to the power 5 Newton, how long does it take to increase the speed of the train from rest to 80 meters per second? So first of all, take note that we're given mass. We're given mass of the train, and take note that we're given the force. The force, because we're told that the locomotive exerts a constant pull. Pull is a force of 7.5 times 10 raised to the power 5 Newton. Now, with your mass and force, you can calculate the acceleration. With your mass and force, you can calculate the what? Acceleration. And once you calculate the acceleration, what do? Use your equation of motion. What the examiner asked you to calculate here is the time it will take. How long does it take to increase the speed of the train from rest? So we are looking for time. The train moved from rest, so initial velocity u is 0. You can see the solution on the screen. Are you following, right? Initial velocity is 0. Now the final velocity was given to be 80 meters per second. Now you think, if you know your acceleration, which you calculated using Newton's second law of motion, and you know your initial velocity, which is u equal to 0 because the motion started from rest, and you know your final velocity, which is 80, you're asked to find time. You see clearly that the information given to you fits the first equation of motion. First equation of motion is v equal to u plus at. So all you now need to do is to substitute. Once you substitute, you calculate your time. That is how you solve this question. The next is question number 28. Question number 28 is a real-time exam question as well too. Question number 28. We are on page 18 now. Page 18. That question that is given there reads, a constant horizontal force F of magnitude 25 Newton is applied to a block of mass M1 equal to 6 kilogram, which pushes against a second block of mass M2 equal to 10 kilogram. The blocks slide over a frictionless horizontal surface. Calculate the acceleration of the blocks. And then you are asked to calculate the horizontal force applied to the second block by the first. So solving this problem is simple. Get the total mass. Just add up the mass so you get a single mass. The first part of the question, you were asked to calculate the acceleration of the block. So if you add the two masses and you get one single mass, you are given force already in the question. Force is equal to 25 Newton. So you apply your Newton's second law of motion to now calculate your acceleration. So you can see the total mass is 16 if you add 6 plus 10. And then your acceleration is force over mass from Newton's second law of motion. So that is it. Are you following? Now you are asked also to find the force of this, the second mass on the first. The horizontal force applied to the second block by the first block. What is the force applied to the second block by the what? First block. Remember that both of them are moving with the same acceleration. That acceleration which you calculated, the acceleration is 1.56. The blocks are together. According to the question here, you were told that the second block pushes, the first block rather, pushes against the second block. So it is something like this. You have something, like this pan. Let this be the block, and then the next block pushed against it. So they come together and they are moving. So they are moving with the same acceleration. That's why you had to even add both of them in the first place to get a single mass, and then use it to get the acceleration of this system together. Now both of them are moving with the same acceleration, which we've calculated 1.56. Now using that acceleration, you can now determine the force of the first mass on the second mass. You can calculate the force of the first mass on the what? Second mass. The only thing is that the value of the mass you are going to use will be the second mass. So it's going to be F1 on 2, force of mass 1 on mass 2, equal to mass 2 times the acceleration. Remember, you are calculating now the force that mass 2 is receiving. That's why you are using M2 to obtain that value. You can see the calculation there on the screen, and then everything is 15.6 Newton. Please, make sure you solve all these questions tonight. Make sure you solve all of them. All these questions I'm pointing to, solve all of them. Together with those questions in part 1 and part 2. Make sure you know how to solve all of them. The reading part of this course is quite straightforward. No big deal about them. Are you following right? No big deal about them. Now question number 21 and 29 is also a real-time exam question. That system is what we call the Atwood machine. That system is what we call the Atwood machine. I'm not going to talk about that because in part 1, I guess, in part 1, the very first thing I treated there was dynamics. And like I said, under dynamics, you must know how to solve problems on tension problems. One of the ones that most examiners actually like asking questions on is the case of an elevator. And there was this particular question in this your year's manual, this sets manual, where they talk about somebody, pulling water from a bucket from a well. That is opposite of elevator. Elevator comes down. If you are pulling your bucket, fetching water from well, it's as if you're elevating. You can be asked to calculate the tension in the rope there, so you should know how to handle that. Part 1 video lesson solves all of them. They are just all about formula. Dynamics is simple but terrible if you do not have the basics of it. On this channel, I've had video lessons that I treated the concept of dynamics very well. Then in the exam focus revision video, part 1 of it deals with your dynamics full time. I finished work there. So help yourself there. Let's look at question 30. You can see the well case. The well case, you can see it there. It's a crystal clear exam question. Take notes. This question, some of you will see it. Question 32. Very interesting question your examiner asked this time around. Take note of it, please. It's an inclined plane problem. But the inclined plane is rough. That is why they gave you coefficient of friction. In fact, let me read out the question. That's question number what? 32. I'm in question number 32 now. Question 31 is also your exam question. Those are, and let me tell you, like I've mentioned, your exam questions will be very simple. They will be very simple. Just make sure you follow my instructions. There are no two ways about it. The way you see these things, very simple and soft there. This is how your questions come. Don't expect to see questions where they will be, they will require you to meander like this, meander. Nobody does that for you, or to you rather. Like I said, all your worked examples in your textbook, they are actually reflections of what you have in your workbook. And the video lessons cover them, like I said, together with this revision that I am handling. So take notes, make sure you follow through. Question 32 is real-time exam question. Question 31 is also real-time exam question. It's a friction problem. Question number 31. I think we are actually in chapter 7 now. Applications of Newton's laws of motion. Yeah. Newton's second law, to be specific. So make sure that you take into consideration question number 31. The coefficient of static friction between a box and the flat bed of a truck is 0.4. What is the maximum acceleration the truck can have along the horizontal direction if the box is not to slide? In the case where the box is not to slide, it is expected that there is no motion as at that moment. And simply put, our frictional force in that case will be equal to mass times acceleration. Frictional force will be equal to mass times what? Acceleration. The video is not clear. Did that one just start happening? I'm sorry about that. Permit me, let me see. Let me boost the network. All right. I needed to boost the network so it would be clear. Someone just said that it wasn't clear. Okay, so I was trying to explain that solution to question number 31. Okay, like I told you, everything about application of Newton's second law under dynamics, where you treat tension, is all about formula. Are you following, right? For that question number 31, the formula you're using is simple. Frictional force is equal to mass times acceleration. Because it's static, the frictional force in that case, you're using your formula that frictional force on its own is coefficient of static friction times the normal reaction. And that's the formula you're seeing on the board. Normal reaction for an object that is placed on maybe a horizontal surface. Normal reaction is the same as the weight of that object, mg. You can see everything there. Now, for maximum acceleration, you observe the masses cancel out. As the masses cancel out, you have the coefficient of friction, that thing that looks like U, that sign that looks like U. Coefficient of friction times acceleration due to gravity. Then you substitute and solve. Please take note, I just said something just now. On a horizontal surface, all right, Okora for John, Udochukwu, it's clear now. All right, I am glad that it is clear now. Please, once it goes blurry, let me know. I'll have to post the network so that it will become clearer. Normal reaction on a horizontal surface, a flat surface. Normal reaction, I usually use capital N for it. You can see it as capital R. It doesn't matter. Capital R. You can use any symbol you want. On a horizontal surface, flat surface, normal reaction is equal to the weight of the object, mg. Now look at question number 32. On an inclined plane, normal reaction is no longer equal to the weight of the object. It's no longer equal to mg directly. Rather, normal reaction will be mg cos theta. You can see my analysis on question number 32. Question number 32. Now, in that question number 32, let's see. Remember, we are in chapter 7 now of your workbook. A block is placed on a plane inclined at 30 degrees relative to the horizontal. If the block slides down the plane with acceleration of magnitude g/3, determine the coefficient of kinetic friction between the block and the plane. Determine the coefficient of kinetic friction. In the case of kinetic friction, the object moves. The object does what? Moves. In question number 31, the object is not expected to move. That is why we did not do any resultant force analysis there. We just used frictional force equal to mass times acceleration in that question 31. In this question 32, you were told to calculate the coefficient of kinetic friction. This object is going to slide in this case. I decided to show the diagram. So the mass will slide on that inclined plane. It will slide down, to slide down the inclined plane. So you have to calculate the coefficient of what? Kinetic friction. Now observe, when an object is sliding on a rough plane, on a plane that is not frictionless, a plane where you experience friction. If an object is sliding down, there is a force pushing the object down. We call it force parallel to the plane. The formula is F equal to mg sin theta. As the object is sliding down, since there is motion and the surface is rough, how do we know that the surface is rough here and that this is a friction inclined plane problem? That is why they ask you to calculate the coefficient of friction. If there is no friction, nobody would ask you to calculate coefficient of friction or give you the coefficient of friction. So if the object is sliding down this way, F equal to mg sin theta, there will be an opposing force trying to tell the object not to go down, but rather remain where you are or move in the opposite direction. That opposing force is your frictional force. And from the fifth law of solid friction, frictional force is directly proportional to the normal reaction, which gives us the formula frictional force equal to coefficient of friction times normal reaction, capital N. So all you now have to do is to apply all the necessary formula on an inclined plane. When the object is to slide down like this, force is equal to mg sin theta. The frictional force opposing it will be F. I can use FR. I think I used F. I didn't show it in the working here, but it's FR equal to coefficient of friction times normal reaction. And our normal reaction here, like I said, is mg cos theta. You can see it showing on the screen in the solved work. Mg cos theta rather. Normal reaction is mg cos theta. It is opposite. That normal reaction, right, acts perpendicular to the plane. It acts perpendicularly to the plane. The formula is mg cos theta. So if frictional force is equal to coefficient of friction times normal reaction, and normal reaction alone is mg cos theta, it simply means that the frictional force is going to be equal to coefficient of kinetic friction in this case times the normal reaction, which is mg cos theta. So you now have coefficient of friction, which is mu. That thing that looks like u, it's pronounced mu, it's a Greek symbol. Mu mg cos theta. Now look at the formula I wrote there. Along this plane, you will now apply Newton's second law of motion with respect to the resultant force acting along this plane. You know that the object can slide down under a force given as mg sin theta. We can take that force as positive. The opposing force, which is the frictional force, which, like I told you, is coefficient of kinetic friction in this case times the normal reaction, and the normal reaction is mg cos theta. So you're going to have that along this plane, you have one force pulling down, which is mg sin theta, minus because you have an opposing force, which is mu mg cos theta. This resultant force along this plane has to be made equal to the net force. The net force according to Newton's second law of motion. And the net force is ma, mass times acceleration. So from what I've just said here, we have F pulling down minus Fr opposing. F pulling down is mg sin theta. Fr opposing is mu mg cos theta. So make it equal to ma. You are seeing it as I derived it, on the screen. Mass is common to the three terms here, so you can divide through by mass and then make A subject to a formula. You see that G is common to the left-hand side. Factorize the G, and you have that formula that acceleration A is equal to G times sin theta minus the coefficient of kinetic friction in this case times cos theta. Substitute your values as given, and then you solve and obtain your coefficient of friction. The value is 0.12. The next problem is on equilibrium. We are in this question number 33. Of course, the knowledge used there is clockwise moment equal to anti-clockwise moment. And I want to tell you guys that in the revision video lesson, part 1, part 2, exam focus revision part 1 and part 2, I think in part 2 or part 1, I've forgotten, you can check, I analyzed every single thing about equilibrium. Equilibrium of parallel coplanar forces and equilibrium of non-parallel coplanar forces. Parallel coplanar forces is the case you are seeing on the board in that question number 33. Non-parallel coplanar forces is the case where you do resultant of forces. For example, like this particular diagram, question number 26. These two forces, 20 Newton and 35 Newton, are referred to as non-coplanar parallel forces because the two forces, 20 Newton and 35 Newton, they are not parallel. One can ask you equilibrium problem there. One can ask you equilibrium problem using this question number 26. We refer to it as equilibrium of non-coplanar it's not non-coplanar. We refer to it as equilibrium of non-parallel coplanar forces. Non-parallel coplanar forces. Because the forces are not parallel. But this one that most of you are used to, this one on question 33, is parallel coplanar. They can ask you a question on both of them. They can. You can see the one of parallel coplanar forces. In part 1 or part 2 thereabout of Physics 101 revision, a video by GMAETS 41, I analyzed everything, even solved question for case of non-parallel coplanar forces, and I actually released one wonderful formula, that I derived from the concept of tightrope walker case, because tightrope walker case is also an equilibrium related problem. A case where maybe if I have a rope tied to two ends straight like this, and someone is standing on the rope, or you place a mass on the rope, You know that the rope will depress down, the rope will come downward. So you have a diagram, a straight line first, but this time around it bends this way. You have angles fixed. I took my time to explain all of those things. You know, there are certain key areas of physics that requires you to see me displaying the power of the GMAETS 41 on the board. And all of those things, I have done them for you, like I said. Are you following, right? I've done them for you, like I said. Areas that require that I demystify all of the things you need on board. Part 1 and part 2 of the revision. This part you are now considering part 3 as we are rounding up for me to give you final guideline and instruction, pointing out key exam questions from your manual. They don't require me to stand solving anything on the board. Your manual problem are just 1 plus 1, especially the ones that form your exam question. Okay, so please, for your equilibrium, make use of the revision video lesson, I think part 1 or part 2. So I would skip this. Question number 34, you won't see it in your exam. Question number 34, you will not see that question in your exam. So on your own, if you want to study it, it's a business, you won't see it. Yes, you won't. The reason is because of the nature of exam you are going for. If the exam you are going for were to be theory, of course, these are the type of questions you would have been expecting. You would have been thinking of. These are the type of questions you would have. In fact, last set Physics 101 workbook is far, far tougher than this year's Physics 101. Yeah, and that is why that last year in the revision, I did not even make reference to their workbook. Last set, in their revision, I didn't make reference to their workbook because their workbook was not a reflection of what the exam question will look like. But you see this, your set. The very first day I saw the workbook, I smiled and I said, well, I love it. This is what the examiners are meant to do. Not to give some kind of random questions. I mean, you want to give questions based on what you are teaching, based on the topics that the students are covering. Unlike the one that I think Chem 101, they tried, but they still did not follow real-time, expectation of what your exam would fully look like with respect to the topics. Although there are some exam-related questions there, but not really much. I'll still highlight on them before your Chem 101. So question 34, we are going to skip it. Are you following, right? But you can, on your own, if you still want to know that, I want to learn how to solve this question, you just cannot tell. Go back. You can go to GMAETS 41's TikTok account. GMAETS 41's TikTok account. I actually released a short video where I solved that. Or you can go to the workbook playlist, trace Physics 101 for last set. But all of those things are a waste of time, like I said. You won't see this question in your exam. That's the truth. But all these reference I'm giving to you were the places that I solved the question, and it's in video format, so you can see it fully. So we are moving on. Work, energy, and power. Good. Another place we have to give serious attention to, because in part 1 and part 2, I did not touch work, energy, and power. Now you are meant to know the definition of work, all right? The definition of energy and the definition of power. What is said to be done when a force applied to an object moves the object through a certain distance. The distance is actually displacement. Okay? The formulas of work. Know all the formulas of work. Know all of them. Know all of them. Because it can be thrown to any direction where you would require the knowledge of any one of the formula to calculate anything. And you need the formula of work to be able to handle power very well. One of the formula of work is that work is force times displacement. Now, if the force is inclined at an angle, the formula for work will be force times displacement times the cosine of the angle that the force made with the horizontal. So you have Fs cos theta. Another formula of work is work done in a force field, which is equal to potential energy formula, mgh. And of course, you know that work is dimensionally the same as energy. So if we are now talking about mgh, which is the work done in a force field, when you're taking something up and down, So you want to also know that work is equal to half mv square in terms of kinetic energy. Be aware of that. Another formula of work is work done by a variable force. Work done by a variable force. A force that changes with respect to something. Question number 36. Question number 36 covers that work. And this is the first time they are actually asking a question, I could say, since 2010 or so. This year they brought this question like this. In fact, in the video lesson that I taught specially, when I was teaching all this topic, the video lesson that I taught work, I solved a question on work under variable force for 2 dimensions. Yeah, 2 dimensions. This one, the work was given, the force was given as 1 dimension. So this is the simplest case. I solved for 2 dimensions, where you convert the 2-dimensional work problem to 1-dimensional work problem, and then you integrate and solve. But one thing I want to say for sure I know is that your examiner they won't give you a question where the force will be 2-dimensional. What do I mean by that? That is, the force contains the x and the force contains the y. They won't. In the video lesson, I solved problem like that. Not clear? Okay, let me boost the network. We shall soon be rounding off. I think after this part, we'll be looking at the last part. All right. So I hope it's pretty clear now. I hope it's pretty clear. So what I'm trying to say in essence is this particular question. In fact, they might just even lift it exactly the way it is in this question number 36. Question 36. Anyway, let's continue. Work done by a variable force. Then you should also be aware of work done by a spring or work done on a spring. Where you bring in the concept of Hooke's law. That work formula that is half kx squared. Half kx raised to the power 2. That k is your first constant. Force constant or stiffness constant or elastic constant or spring constant. If you do not use work equal to half kx squared, you can use the formula work equal to half Fe. If you are using force, it will simply be F times x. Fx. That E is extension. X is also extension. So if you're using x or E, the choice is yours. If it is first constant that you're using the formula, the extension will be squared. First constant is k. You can see question 35. Question 35, that's what I'm talking about. But if in the question you are not given first constant, that it is force and extension that are given to you, then the work formula will be half Fe. Take note of that. Now you see that question number 35 is straightforward. That is not something I waste my time on. But that question number 36, let's look at it. How do you handle that? It's simple. Question 36, there you are given force. That force is given as a function of displacement or distance, as you might choose to call it. That x there is distance or displacement, as you might choose to call it, like I said. Are we together? Now the force was given to be 3x squared plus 2x. The force, all right, I think you're fully okay. Okay. Okorafor, thank you for the response. Now, that force is dependent on x. So if you apply the work formula, which is equal to F dx, it's meant to be F times x, force times displacement. But the displacement in this case will be dx. It will not just be normal displacement because the force was given as a function of displacement. So you're using the formula that work is equal to F dx. Now take note, the next semester you guys are going to do Math 102, where you study differential and integral calculus. GMAETS 41 is here waiting for you for next semester. Where I will break all those things 1 plus 1 because they are actually very simple. Those things you are learning, they are very simple, especially at this level, right? So make sure you grab your A and your first class from this semester and this level. Because you have your work formula to be force times dx, that is f dx. Anytime you multiply any quantity by what we call a differential coefficient, that dx is a differential coefficient. Dx, dy, they are differential coefficient. Anytime you multiply anything by this differential coefficient, to solve that thing, you must integrate. You must integrate. That is why the formula finally that solves this work is W equal to integral f dx. That is telling you integrate the force with respect to x. Integrate the force with respect to x. And of course, that is why the force has been given to depend on x. So simply what you do is to substitute for the force using the value given to you, 3x squared plus 2x. So our work is equal to integral. The limit of integral was given to you in the question. You are told to solve this thing from x equal to 0 to x equal to 2.0. That is x equal to 0 to x equal to 2. We call that the limit of integral from the starting point to the end point. So if you do the integration, 3x raised to power 2, integrate the x raised to power 2. All you do is add 1 to that power 2. You will get power 3. Simply x raised to power 2, add 1 to that 2. And then divide by the new power. Divide by the new power. Mary Jane, you are welcome to join us. So if you have 3x raised to power 2, you integrate that x raised to power 2, you get x raised to power 3, then all over 3. The 3 will cancel out. You'll be left with x raised to power 3 as you see in the next line. As you're seeing in the next line. Then move on to 2x and integrate with respect to x. Pick that x alone. That x alone is raised to power 1 in that 2x. Add 1 to the power, you will get 1 plus 1, which is 2. Then divide by the new power you got, which is 2. 2x, you have to integrate it with respect to x. So pick that x alone. It is the x you're integrating. X standing alone is x raised to power 1. To integrate it, add 1 to the power and then divide by the new power. If you do that, you should be getting x raised to power 2 all over 2. That over 2 will cancel the 2 that was multiplying the x from the question. So that everything, after you integrate, you can see the square bracket there. The integral value of the force with respect to x is x raised to power 3 plus x raised to power 2. Now the limit of integral from 0 to 2, what you are meant to do now is go back to what you integrated, to the value you obtained after integration, which is the x raised to power 3 plus x raised to power 2. Wherever you see x, replace it with the upper limit 2. Then minus, replace that x again with the lower limit 0. Now let us look at that x raised to power 3. So you remove that x and fix the upper limit 2. It's going to be 2 raised to power 3 because the x is carrying power 3. Minus, go back to that x raised to power 3 again, remove the x and fix 0, the lower limit. It's going to be minus 0 raised to power 3. That is the reason why you saw 2 raised to power 3 minus 0 raised to power. It's meant to be 0 raised to power 3. I made a mistake there. But thank God the mistake does not affect the solution. Thank God, because 0 raised to any number is 0. 0 raised to the power of any number is 0. That makes me a human, okay? So manage it. So that 0 is supposed to be raised to power 3. Are you following, right? Good. Then plus, go to the x raised to power 2 you obtained in that integration. Wherever you see x, remove it, fix the upper limit, minus, fix the lower limit again. Whatever is happening to the x in the value you obtained when you integrated will also affect what you are substituting for. So in place of that x raised to power 2, remove the x, fix the upper limit 2. That's going to give you 2 raised to power 2. Then minus, fix lower limit 0. That will give you 0 raised to power 2. Simplify that and you get your work. The work is 12 joule. Like I said, one thing I am 100% certain is that they won't give you the type of question that I personally solved in the video lesson when I treated the topic work, energy, and power. It's separate from the normal revision, the 2-part revision video I told you. You know, on this channel, like I said, all your topics, all of your topics, Math 101, Physics 101, Chem 101, your practical courses, Physics 107, Chem 107, they are there. So please, I'm just joining. Please, where can I watch the previous one? Who's a trickle? All right, you can watch the part 1 and part 2, because this revision contains just 3 parts: part 1, part 2, part 3. Part 1 and part 2, check this channel, GMAETS 41's channel. Go to the playlist, then take your time, gradually scroll. You would see a special playlist titled Exam Revision Playlist at your exam revision class. There you have all the revisions for your remaining 3 interfaculty core courses: Math 101, Physics 101, Chem 101. Physics 101 is at the top. So you see part 1 and part 2 there. Enjoy it. Okay? So back to what we are talking about. We are done with the one of work done by variable force. Please, this particular one, focus on it. Focus on it. They are testing you on that, which I am pretty sure some people will see question on this. Yes, because this is the first time they are asking a question on this type of work. So make sure you understand what I've explained and what was solved here. Let us move on, please, to question number 37. Question number 37 is quite simple and straightforward. A constant horizontal force of 10 Newton acts in the direction of motion for a displacement of 5 meter. Neglect other forces. Find the final speed. Neglect other forces. Find the final speed. Now, if you look at the question given to you, you know the force, right? Now, the displacement was given to you, which is 5 meter rather. The force is 10 Newton. Displacement is 5 meter. When you know your force and you know your displacement, you can calculate work. Work is force times displacement. Now we are asked to find the final word, speed. You know, I told you that work is also equal to mgh. It's also equal to half mv squared, because work is dimensionally equal to what? Energy. And we have 2 types of mechanical energy: potential and kinetic. So to solve this question, the work formula, force times displacement, will be equal to the work formula, kinetic, half mv squared, because you're asked to calculate velocity. From there, you make velocity subject of the formula. Now, watch out. For this particular question in your workbook, you were not given the value of the mass. You were not. That is why in the final answer, you can look at this. In the final answer, V equal to 10 over square root of m in meter per second. Because the mass was not given to us in the question, you cannot substitute for the mass. In your exam, most likely the mass will be given to you. So if the mass is given, you fix up the value of the mass and then you simplify. If the mass is not given to you, don't panic. Leave your answer in terms of mass, just like you have it in the solution of the manual. Let's move on to the next question, number 38. Still another real-time exam question. It deals with power. It deals with power. So you want to make sure you know how to solve this question. You know, before this day, I remember when I was solving, I was doing live solving of some of the chapters of this Physics 101 manual or workbook. I stated it clearly that most of the questions in that workbook, calculation questions in that workbook, are your exam questions. I said it. I have never said something like that for previous sets before in their workbook, because their workbook previously is not a reflection of the nature of the exam question that students are going for. So I usually do independent revision for them of anything about their workbook. But you see your set, I'm saying it seriously. If you're not careful, almost all the calculations you people will see in the exam question might just even come from the manual directly. So make sure all these questions I'm pointing to, it's not all of them. There are some of them I told you they won't come, just forget about them. The others, make sure you study them very, very well. And do not forget, like I said, the part 1 and part 2. Because the part 1 and part 2, real-time exam questions on those topics as well too. Of course, I did board work there, so I taught. It's in video format. Broke down a lot of things, so you can learn very well also from there. So we are given this question on power. A car of mass 1,200 kilogram accelerates from 15 meters per second to 25 meters per second in 6 seconds. Assuming no losses. Which question am I reading? I'm talking about question number 38. Right? Question 38. Okay. Assuming no losses. Find the average power delivered by the engine during the acceleration. Find the average power. So while I was reading this question, I want to believe that you would have been following through with the parameters. Question 38. The mass was given to us to be 1,200 kilogram, that is 1,200 kilogram. The initial velocity 15 meters per second. The final velocity 25 meters per second. Time was given to us to be 6 seconds, and we are asked to calculate the average what? Velocity. Sorry, the average power, I mean to say. You know, power is defined as the rate at which work is being done, the rate of doing work, the rate at which energy is expended. Can define as rate of doing work, rate at which energy is expended. So the base formula of power is work over time or energy over time. Therefore, you should be able to know or remember all the formulas of power. One of the formula of power, the basic formula rather, is work over time. So start thinking of all the work formulas I mentioned earlier. You can use each of the work formula to generate another formula of power. So if work formula, we have 5 of them, then power formula here will be 5 plus another one. That another one is when you have power to be equal to force times velocity. That's when you have power. Not clear enough. Okay, permit me, let me boost the network once again. Permit me, let me boost the network. All right. So I've boosted the network. Once I'm trying to boost, you might be logged out automatically. If I am done boosting it, you'll be logged in automatically as well. So always stay tuned. Don't log out if the network disturbs. I would always boost it, okay? So there is this special formula of power you should also be aware of, that power is equal to force times velocity. That formula is obtained from power formula, which is force times distance over time. I mean force times displacement rather over time. Remember, like I said, power is work over time. So if you are using the formula of work to be force times displacement over time, displacement divided by time will give you velocity. Therefore, power is force times velocity. So you want to be aware of that. Another formula of power can be given as power equal to half mv squared divided by t. All the work formulas, all the energy formulas, divide them by time, you get your power. So for this question, we are meant to do that. If you look at the parameters given to us, we have kinetic energy parameters or data, kinetic energy information in this question. And hence we can attack the question, via that approach. Permit me, please, let me, oh no, I thought my charger is here to plug my device. But anyway, let's continue. So from this information given to us, to solve for power is going to be kinetic energy divided by time. And our kinetic energy is half mv squared, 1/2 times mass times square of velocity. Now they gave us final and initial velocity. So you have to square the final velocity minus the square the initial velocity, which means the formula will no longer be as simple as half mv squared. There are 2 velocities there, the final and the initial. So square each of them and subtract. You can see the formula there as I applied. When you substitute, you can solve for power. Now remember too that there is this power formula that can be obtained. That question is asked with respect to when you are pumping water to an overhead tank. Many of the houses, or even your own house, you have tank, placed at a certain height, and then usually the pumping machine in the compound pumps water and the water is sent vertically to the overhead tank. When a question is given to you on that and you have to calculate power or what have you, the formula to use for power there is power equal to mgh over time. Because likely the mass of the water being pumped to be given to you, acceleration due to gravity is constant. Now, if you can be given the height, of course, the height at which the tank is being placed. Then the time. With that, you can calculate the power. Or they can give you power, give you mass, give you height, and ask you to find the what time during which the pumping of the water will take place. So remember all of this, like I said, various work formula gives you different power formula as well too. Question 39. Question 39, very important. Another strong exam question. That question 39 focuses on a roller coaster car of mass 50 kg, which is released from height at 40 meter. That height is 40 meter, capital letter H. Ignore friction. What is its speed when it reaches height H equal to 5 meter? Real-time exam question as well too. Now you look at, this thing was released from a height. When something is at a height, it has potential energy. When you release it, the potential energy will convert to kinetic energy. Now, based on this, you apply the principle of conservation of mechanical energy. Conservation of mechanical energy. The law of conservation of energy. Energy cannot be created nor destroyed, but convert or changes from one form to another. We are dealing with potential energy and kinetic energy here. In physics, we focus more on mechanical energy, where we study potential and kinetic energy. So you use the law of conservation of energy in this case, where you are going to do mgh1 plus half mv square 1 equal to mgh2 plus half mv square 2. That 1 and 2 you are hearing means final and initial values, right? The roller coaster was released from height, although the initial height we use capital letter H according to your manual, but you can choose to use H1 and H2. The choice is yours. Okay, but now look at the condition. If you look at this work being solved, you notice that mg capital letter H, which is the initial potential energy from the height, something is at a given height, you can release it and it falls. Are you following, right? Something at a given height, it has potential energy. Once you release, the potential energy will convert to kinetic energy. At this height, from height, there is no initial kinetic energy. The reason is because at a given height, when you have something at a height, you want to release it. At that height, velocity is equal to 0. So kinetic energy initial will be 0. Once you release, the kinetic energy will convert. The potential energy will now convert to kinetic. So you have final kinetic energy as you release. But when it is at that height, there is no kinetic energy. All the energy there is what? Potential at that time. So if you apply those things, you're going to get, your mgh plus 0, which is initial kinetic energy, equal to mg small letter h final potential energy plus half mv squared. You notice that v squared now appeared here, the final velocity which you're asked to find. All right. I played with the formula. The masses can cancel out and then make v subject a formula. The formula looks like escape velocity formula. The velocity is square root of 2gh. But you see, the only thing is that the height, you must take the difference. The total height minus the point at which you're asked, the height at which you're asked to calculate the velocity. And that is how simple you solve that problem. So we are done with this concept of work, energy, and power. Question number 39 is energy problem directly. Question 38 is power problem. But remember that there are other aspects of power formulas that you can be tested on. I told you one about mgh over time. Then question 35, 36, 37 are work-related problems. So you want to take note of all of this. Everything in this chapter 8, they are key exam questions. Let's move on to chapter 9, momentum, right? Chapter 9, momentum, I have solved problems on that in the revision section, I think, part 1, I dealt with that concept, if I'm not mistaken. Yeah, I think after dynamics analysis in part 1, the next thing I touched was momentum. So I'm not going to waste time on this momentum concept here. The only thing I would do, you have impulse as well too, so you take note. The calculation is there. Question 40, very important. You take note of that. Question 41. Question number 41. A 2.0 kilogram object moving at 3.0 meter per second collides with a 1.0 kilogram object at rest. The coefficient of restitution is 0.4. Find the loss in kinetic energy during the collision. That question, don't bother yourself about it. See that question particular, don't bother yourself. It won't come out. Question 41. Question number 41. Don't bother yourself. It's not as if that question is not an exam question per se, but for the exam you're going for. If they're asking you anything about coefficient of restitution, they will just ask, find coefficient of restitution directly. This combination that went this way, meandering, they won't ask you. I assure you of this. Are you following, right? 100%. They won't ask you. Question 40. It's a real-time exam question where you have to calculate impulse. Impulse is mass times change in velocity. But I want to take note of what happens here. Now, let me read out that question number 40. Let me read it out so that you would notice why we have a negative value in one of the velocities. Question 40. A 200-gram ball is dropped from rest. So it's just like maybe from a certain height you dropped it and strikes the floor at 4.5 meter per second. So the initial velocity, is coming down, right? Now we are told it rebounds vertically with a speed of 3 meter per second. So the first speed is 4.5 meter per second. The second speed is 3.0 meter per second. Calculate the impulse delivered by the floor to the ball. Calculate the impulse delivered by the floor to the ball. Now, when you release the object, it was coming down, downward motion. You can decide to say the downward motion should be positive velocity. Remember that velocity is a vector quantity. Velocity is what I said, a vector quantity. So direction matters. Direction matters. So if I say that, okay, coming down should be negative, then if the ball hits the ground and then rebounds, going up, I would take it as negative. That choice is mine. I can decide otherwise that coming down should be positive. Now, once it hits the ground, it's going up, changing direction. So the upward velocity should be negative. That is why in this solution, you found out that one of the velocities, I gave it as positive and the other velocity as negative. However you solve it, you will still arrive at this answer, 1.5 Newton second. However you solve it, you will arrive at this. Are you getting me right? Now I have 3 minus 4.5, giving us plus. Even if you had done 4.5 to be positive, downward velocity, and then upward final velocity to be negative, you'll be getting -3, -4.5, which is v minus u. Assuming that the final velocity, going up velocity, you give it negative. It's going to be -3, then minus the initial velocity, which is 4.5, positive there. So I am saying that however you apply the sign, whether you take the initial velocity to be negative or the final velocity to be negative, while the other one positive, you still arrive at the same answer. If you take the final velocity, the smaller velocity as negative there, the final answer of impulse you will get will be negative, but then you take the absolute value, so you drop that minus in the final answer. So that is that. This question number 41 will not be asked, so no need of wasting our time. Let's move on. Although I've solved it, you can learn it. You're asked to, they gave us coefficient of restitution, and we're asked to find the loss in kinetic energy. Let us move on to question number 45. Very important exam question. Very important exam question. Give attention to it as well too. Please remember all the questions I'm telling you, they are very important, and I've shown you the solutions. I've solved them. At the end of this live class, a copy of this part 3 revision and final guideline to your exam will be made available. You will see it, so you can still come back and watch. Take your time and still see the solution. At least I took my time to explain, a little of the things I solved here. Does that make sense, right? The other chapters, chapter 1 to a part of chapter 3, I did live videos on them. That is why you didn't see some of them here. Okay, so you can check the live video section. That's the live section of this channel. Everything you need to enhance your studies from the comfort of your home, to help you understand all the things they teach you in lecture hall that sometimes you even get confused. Some of you have heard reports. You'll be like, you don't even understand what this person is doing as in what this person is teaching and whatever. But come on, you can't keep complaining. No. A serious student is one that tries to find solution to his problem. And you see, as long as your works are concerned, imagine Unizik as it stands. I run physical tutorial in Unizik as well to GMAT 41. I run physical tutorial. I talk about that regularly. You must not see me every day run after you to talk about tutorial. Second semester is still there. Don't miss the chance of joining us. Full-time online classes are also available. Like I said, even next semester, everything you're doing in your core interfaculty courses next semester, Math 102, Physics 102, Chem 102, Organic Chemistry, Physics 108, Physics Practical, Electricity and Light, Chem 108, Organic Chemistry, Qualitative Analysis. That thing you did, you call salt analysis. Organic Chemistry has its own. All of the analysis, all of the video lessons are available from beginning to end. So please make sure you start learning on time. Your first semester is really understandable. Mistakes we make sometimes could even be as a result of the school themselves. Number one, no good orientation to students so that your friends will know really what you should know. Number two, you are naive, inexperienced. So confused even when you enter the environment. This one will come from here, the other will come from here, tutorial will come, there books will come to be sold, and nobody is guiding you. No clear information from the school for you people to know what to do and what not to do. Late admission sometimes. Some of you contemplating, do I need tutorial? Well, not everybody needs tutorial anyway, but many out of 100%, 70 to 80% students need tutorials. There are no two ways about it. Is it not in this country that many students have weak foundation? Many students have weak foundation from their O-level works. That's the truth. But the good thing is that God has actually made arrangements for you guys through GMAT 41. Please don't joke with GMAT 41. It's not about me. Whenever I talk about this channel, I focus more about what God has used somebody to do for you people. Second semester is there, like I said. Let's continue. Question number 42 is a crystal clear exam question, where you are asked to calculate the common velocity in a case of inelastic collision. How would you know that collision is inelastic? Now, under collision, we have types of collision. We have types of collision. We have explosive collision, explosion. That is also called one-to-many type of collision. One thing will just explode and scatter. You have many particles from that one thing that exploded. In that case, the final kinetic energy is greater than the initial kinetic energy. Because after the explosion, the particles that split and they're going up, they move with greater velocity. So final kinetic energy is greater than initial kinetic energy, which in other words mean that initial kinetic energy is less than final kinetic energy for explosive collision or explosion. Then we have inelastic collision. Under inelastic collision, we have perfectly inelastic and then just normal inelastic collision. In inelastic collision, we also refer to it as many-to-one type of collision. You could have two or more things collide, right? Now, if the collision is inelastic, when they collide, They will not stop immediately. They won't. They might just move a little, but they will stick together. They will stick together. Inelastic collision, when they collide, they will stick together but move a little with one velocity. That velocity is called common velocity. You must have heard about it. In question number 42, you could see where I wrote m1 plus m2 in bracket, then vc on the right hand side of the equation. That vc is your common velocity. It happens in inelastic collision where the object sticks together. Perfectly inelastic, when they collide, they tend to come to rest. They don't move. They come to rest. In inelastic collision, like I said, it is many to one type of collision. Different things collide and they might stick and become one. The final kinetic energy in inelastic collision is less than the initial kinetic energy. You want to take note of that. Then we have the type of collision called elastic collision. In elastic collision, there is no loss and there is no gain in kinetic energy. No loss, no gain in kinetic energy. That is also known as many to many type of collision. Many to many. Two or more objects may collide, and after colliding, they separate again and move apart. Are you following, right? They separate and move apart. How do we get part 1 and 2? Once again, part 1 and 2 revision is on this channel. I have taken my time to create a special playlist specifically for your exam revision. So check the playlist of this channel. Check the playlist. Then when you tap on the playlist, scroll gradually while you watch, while you observe. You will see a playlist that is tagged exam focused revision. Are you following, right? Yeah. Exam revision playlist. Thereabout, I've forgotten how I placed it, but something of that kind. Exam revision playlist. Okay. You will see a thumbnail where I am inside a vehicle with someone, right? With the trademark of the GMAETS 41. You would see this there. This is power. The power of excellence. And I want you right away from where you are seated to say it. GMAETS 41. Whenever you say that, you gain that momentum to go in there and put your examiners to a standstill. They don't have anywhere to dribble you to. It's not done. Not after you go through all the GMAETS 41's coaching. Yeah. Our God and helper Jehovah has always been there to give us the final of the final best, A splashes and first class, if you follow through with the guidelines. So I am done explaining all the concept of types of collision. Are you following, right? Examiners usually like asking questions on inelastic collision where they will ask you of common velocity. But that does not mean they cannot ask you of other types. They can. But you take note. It usually comes on inelastic collision. Are you following, right? Then they can ask you in elastic. Many to many. Many things come, collide and then separate. So you take note of that. Now the formula for conservation of linear momentum and that law of conservation of linear momentum, you expect to know them. In part 1, I've treated all of those things because that part 1 and 2, I did not just come to show one or two things. No. I took those things topic by topic, gave a quick summary, both definition terms, the statement of laws, formulas, and then question. That is calculations. Are you following, right? I did all of those. Getting blurry. I'm sorry. Let me boost the network. Please be patient. Good. I think we are back again. We're back again. So, like I was explaining, right? You want to take note of the concepts. All right, Ernest Chirem Sharp, that's good. So let's continue since it is now clear. So like I said, in chapter 9, question 40, question 42, very important, take note of that. Question 41, I've told you don't bother yourself about it. They can't ask you that type of question. You won't see it. You won't say it. Anything about quotient of restitution, question number 43 is the only thing you can see about quotient of restitution. I'm going to explain that. I've told you about what to know about question 42. Question number 42 led me to talk about types of collision. Are you getting me? And I explained what you should know about it because it can ask you applied question there. They can ask you applied question. Now, when you talk about law of conservation of linear momentum, please remember the formula m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. That is the overall formula. Now, you notice that I used plus plus everywhere. Will the video be uploaded after the live? Yes. Immediately we end the live copy of the video will be available for you so you can still come back. Are you following right? So, I used plus on the left and plus on the right. M1 U1 plus M2 U2 equal to M1 V1. That V is final velocity, you know, plus M2 V2. Please, that formula is in a case where the objects that are colliding, they are moving in the same direction. If they are moving in the same direction, you know, momentum is a vector quantity. Velocity is a vector quantity. Each of the term in that law of conservation of linear momentum formula, M1 U1 plus M2 U2, you know, each of them, M1 U1 is defining momentum, initial momentum of object 1. M2 U2, initial momentum of object 2. M1 V1, final momentum of object 1. M2 V2, final momentum of object 2. Whenever these objects are moving in the same direction, right? Let me assume I tell you that an object collides with another object from behind. It means they are actually moving in the same direction. Maybe this one is in front, the other one comes from behind and then hits. They are moving in the same direction. That's when you use plus all through. Because in that case, the object, since they are moving in the same direction, velocity as a vector quantity will be in the same direction. Positive, positive. Momentum as a vector quantity will also be in the same direction. Positive, positive. That is why that formula will be plus all through. Now imagine this. I tell you that two objects are moving in opposite direction and collide. Opposite direction could be that they are coming this way. Or if they draw the diagram for you, you may see a circular thing drawn, another circular thing drawn, and then arrow is pointing away like this. If you see arrow pointing away like this going this way, this going this way, it means the objects are opposite. Now, if before collision, they are moving in opposite direction, moving against each other. Against each other still means they are moving opposite. Or if you hear that there is a head-on collision, two objects, you know, undergoes a head-on collision. Head-on collision can think of two vehicles that collided. If they collide head-on, it means they faced each other. Are you following? They are not in the same direction. Rather, they are in different direction. In that case, if it happens initially, take note, one of the velocity will be positive. One of the initial velocity, you can say that, okay, U1 should be positive. Therefore, U2 will be negative. In that case, please take note, the formula will take the format M1 U1 minus M2 U2. Where the minus came as a result of U2. You are saying that, okay, if object 1 is coming this way, let me take the initial velocity to be positive, U1. So you now have M1 U1 positive. Then object 2 is coming opposite. Are you following, right? Since it is opposite, the initial velocity of object 2, U2, will carry minus. So that M2 times minus U2 will give us minus M2 U2. So in that case, the formula will be M1 U1 minus M2 U2, no longer plus, because it is opposite movement. Then equal to, now if the objects collide and they stick together, it will be M1 plus M2 in bracket and then the common velocity as you see in question 42 here. But if the object did not stick together, let's assume that the collision is not inelastic. If the collision is elastic, after colliding, they will scatter apart. That's why I told you elastic is many to many. But there's no loss, there is no gain in kinetic energy. But there is a change in velocity. Are you following right? So if they scatter after colliding, you cannot do that factorization as a M1 plus M2 in bracket common velocity. You don't do that. That right-hand side of the formula will be m1 v1. And in fact, the mathematical sign won't be plus. Because usually if they collide and they go apart, moving apart means they are moving in different direction, not the same direction. So it's going to be m1 v1 minus m2 v2. Please take note of this concept in case you see any such statement like that in terms of trying to tell you about direction of motion, so you know how to handle the formula. Please let us look at question number 33. It will help us also a little what I just explained about being conscious, being mindful of direction of motion, because it affects the signs of velocity. Let us see how we use it to solve that question number 43. Question number 43 is based on coefficient of restitution. It's a real-time exam question. Let us see what you were asked to do there. Two balls collide head-on. Two balls collide head-on. Head-on, you know the implication. It means initially they are moving opposite. So you must take one of the initial velocity as positive and the other one as negative. Ball A, 0.5 kilogram, moves at 4 meters per second. So let ball A be our first ball. The initial velocity can be UA. If you don't want to use the A, you can use 1 and 2 to define them. There is no crime. And ball B, 0.8 kilogram, moves toward A at 2.0 meters per second. Take note of this statement. Ball B moved towards what? A. The examiner decided to tell you something about ball B. Ball B moved towards A. So this is what you will do. You can take ball A with its velocity as positive. And then since ball B is moving towards A, opposite direction, are you following? Then you take the velocity of that guy as negative. Which means if you are to calculate the momentum, if you have to use the equation of conservation of linear momentum, it's going to be m1 u1 minus m2 u2. Take note, that minus came from u2. It came from what I said? u2. Good. And then this will now be equal to, let's find out as we move on. After the collision, ball A moves backward at 1.0 meters per second. Take note, after the collision, ball A moved backward. The examiner now specified what happened again. That, okay, this time around, it is ball A that moved backward. Which means as they were coming like this, and then B collided, this A moved backward. This A moved backward. What reason does the examiner even have for telling you that A moved and then moved backward? Why did they highlight it? That is to tell you again that after colliding, there was scattering. Yeah, they moved apart, but they decided to pick ball A and told you something that ball A moved backward. So the sign change, the guy that will carry minus will now be the velocity of A, final velocity of A, which means the right hand side of the formula is going to be MB VB. That one will be positive. There's now to write MA VA. That VA will carry minus because the examiner highlighted that after the collision, A moved backward. They've told you something about the direction. If they moved in the same direction, the examiner will say that they collided and moved in the same direction. Then no need of even thinking of anything negative there. But here you were told that one moved backward. There is something there. That particular guy, its velocity will be 0. And that is why the formula you see on the board there is MA UA minus MB UB. Remember, the minus belongs to B. UB. Brought in that minus on the left hand side of the formula. And then on the right hand side of the formula, where you have the final momentum, B was given to be positive. That's why you have MB VB. But A now, the final velocity of A VA took minus because direction of A changed. Now, why did we have to even apply this formula in the first place? Listen to what the examiner said, or in the workbook you were asked to calculate. Find the coefficient of restitution. To calculate coefficient of restitution, you need all the velocities. The initial velocity of the two objects, the final velocities of the two objects. You need all of them. You need all of them. But if you look at this question, we were given the final velocity of ball A. The examiner said that after collision, ball A moved backward with the velocity of 1.0 meter per second, but the examiner did not give us the velocity of B, final velocity of B, which is VB. So we need to find the value of the final velocity of B. By the way, take note of this question 43, that formula I used, and then look at question 42. They are right-hand side. Notice that in question 42, I did M1 plus M2 and then factorize the common velocity. Reason, the type of collision there is inelastic. So there is a sticking together after the collision. So they will move with common velocity. But this question 43, you notice that the final velocity, there was nothing like common again, because after the collision, there was a movement separately. A moved backward. So there will be nothing like common velocity. You handle each of the final momentum separately. And then don't forget about the signs I explained. Very important. See this question? 43. Many people will say it in their exam. Many will say it in their exam. Calculate coefficient of restitution. You see that they give you all the velocities, the two initial velocities, the two final velocities, without stressing you to calculate any of the velocity in order to get the coefficient of restitution. Or if they want to stress you, the question will come in this format, where you need to find a velocity first, one velocity to complete the three, making it 4, in order to calculate your coefficient of restitution. Okay, let us move on, please. Now that we've known the formula to use in a case like this, because this collision is elastic collision. Yeah, that's what I can say. Many objects colliding and then still separating. You have many again. If you substitute the values given to you and then you solve, you get VB to be 1.125. 1.125. Now, you are to calculate coefficient of restitution. How do you calculate coefficient of restitution? Coefficient of restitution, which defines the extent of elasticity of, collision. The elasticity of collision, that is what coefficient of restitution defines. The formula in terms of velocity, because you can also write the formula in terms of kinetic energy, but I'm going to focus on that in terms of velocity, because nobody's going to bother you on that in terms of kinetic energy. Yeah, you won't see that. In terms of velocity, the formula is simply final velocity divided by initial velocity. But when you now come to this final velocity over initial velocity, how you arrange them matters. How you arrange them matters. And please, I'm not going to give you any direct formula. If you look at this, you saw VB minus, I think it's supposed to be VB minus VA all over UA minus UB. You saw it's E. I'm using E as coefficient of restitution. Please, I don't want you to cram that formula to memorize in that format. This is the best thing to do. Listen as I tell you how to remember the formula of coefficient of restitution. First of all, know that it is final velocity over initial velocity. Take note of that. And then, what is the arrangement of the differences in the final velocity? Because if you come to the numerator, it is difference of the final velocities, denominator, difference of the initial velocities. Now, this is what you should know about how the numbers will be placed. At every point in time, the velocities will be the bigger velocity minus the smaller velocity. Bigger velocity minus smaller velocity. So that, however you calculate your coefficient of restitution, you will get a positive number. So this is going to be, for the numerator, the greater final velocity minus the smaller final velocity. All over, in the denominator, you have initial velocity. The greater initial velocity minus the smaller initial velocity. I repeat, coefficient of restitution is equal to the greater final velocity minus the smaller final velocity, all over the greater initial velocity minus the smaller initial velocity. And I told you the reason for that. Coefficient of restitution can never be negative. It can never. So there is no way you can arrange that formula to get a negative, maybe getting a smaller velocity minus a bigger velocity is never done. So if you come to final velocity over initial velocity, for the numerator final velocity, it is the higher final velocity or greater final velocity minus the smaller final velocity divided by the higher initial velocity minus the smaller initial velocity. Now, let us watch our substitution here. Something critical that you want to take note of. When you start substituting, you don't just fix your value anyhow. You must remember the direction of the objects and hence the signs of the velocity. So our coefficient of restitution for this particular question now is going to be the greater final velocity. Let us look at the final velocities. For object A, the final velocity is 1. You can see VA equal to 1 meter per second. For object B, the final velocity we calculated VB is 1.125. Now 1.125 and 1, which one is greater? 1.125 is greater. So if you are calculating coefficient of restitution for the final velocities here, is going to be the final velocity of object B. Since that object B's final velocity is bigger, greater, higher than the final velocity of object A. So that the numerator will now be VB minus VA. Simply greater final velocity minus smaller final velocity. All over, you come to the initial velocity. Compare initial velocity of A and initial velocity of B. Which one is greater? That one of A is greater than the initial velocity of B. You can see it. UA is 4 and UB there is 2. So that the denominator will be UA minus UB as you see it on screen, or as you're seeing it on screen. Now, the coefficient of restitution will now be equal to, you need to remember the condition of movement of this object. Final velocity of B from the question. Final velocity of B from the question will be positive. Final velocity of A in the question is negative because after collision, the examiner said that A, moved backward. A moved backward. He said ball A moves backward at 1.0 meter per second. So the final velocity of object A, which is VA, will bear minus. It will bear minus. I told you that was what brought in minus in some places in our analysis. I think in the final momentum, the minus MAVA is from the VA. So when you are substituting the value VB minus VA for the numerator, it will be 1.125, which is the final velocity of object B, minus, you want to substitute for final velocity of object A. Since object A changed direction, that value, which is 1, will carry its own minus. So that you now have minus 1. What I'm trying to say is that VA is equal to minus 1. My generator wants to go off, so let me get light set. Let me get light set before it goes off. I'm almost rounding off what I want to do, so we can close for today. It's not easy. So let's see if we can manage this light in case the gen goes off. I cannot top up the petrol tonight anymore. I won't top up the petrol. I don't try. Let me see what happens. So let's see if we can manage this in case the light goes off. Then for the denominator, initial velocity. For the denominator, initial velocities, right? Now you notice that the initial velocity of object A is positive because initially it is object B that moved with, it is object B that we're told moved against object A. So the initial velocity of object B will be negative because that's the guy considered to move opposite to A. While initial velocity of A, UA, will be positive. Remember, in the conservation of linear momentum, the formula you have there is MAUA minus MBUB. So UB bears minus. And then if you go to the final momentum, MBVB minus MAVA. So VA bears minus. Substitute in the coefficient of restitution, and you have your answer smiling at you there. So we are done with everything about coefficient of restitution. Please, coefficient of restitution is simply defined as ratio of final velocity of an object to the initial velocity of that object. It's actually defined as a relative ratio. Yeah, something like that, because it brings in difference in it. But just simply put, the ratio of final velocity to the initial velocity. But remember what I told you about the signs. Very important. About the signs. Very important. All right, guys, I think we've done a lot of job. Let's move on. There is this question number 44. I don't see them asking you anything about that question 44. All right. That one of explosive collision. I don't see them asking you anything about that explosive collision. In fact, they will not ask you. They won't ask you that. Then chapter 10, center of mass. Chapter 10, center of mass. Chapter 10, center of mass. That is question 45. That is question 45. You know, center of mass, there is something about that guy. Question on center of mass can be asked with respect to velocity. It can be asked with respect to distance. With respect to distance. Okay, so you want to take note of the concept of center of mass. Question number 45, you can be asked that. You can be asked that, question 45. Question 46, you can be asked that. You can be asked that, question 46. These are real-time exam questions. Don't know an insect. It's just an insect just interrupted me, you know. So that question number 45, let us read it and see. A 2-kilogram object is moving at 3 meters per second. A 3-kilogram object is moving at 3 meters per second, and a 2-kilogram object is moving at 3 meters per second, and a 3-kilogram object is moving at 2 meters per second in the opposite direction. What is the velocity of their center of mass? What is the velocity of their center of mass? You see, this question is very simple. Now, 1 plus 1. See, if you understand momentum, like I said, center of mass can be asked in different aspects, different ways. It can be asked in terms of momentum. Like in this case, it's actually momentum. Then it brings in the concept of, calculate the center of mass. What is the velocity of their center of mass? That's what the question says. What's the velocity of the center of mass? But now look at this question given to us. Just look at the question. A 2-kilogram object is moving at 3 meters per second. This value given to you already gives you the momentum of that object, because mass times velocity is momentum. And a 3-kilogram object is moving at 2 meters per second. Is moving at what? 2 meters per second. Again, they gave you mass. They gave you velocity. So another momentum has been given. But these two objects, as they move, we are told that the second one moves in the opposite what? Direction. What is the velocity of their center of mass? For the second to move in opposite direction, there is likely collision. There is likely what? Collision. Yes. So, you are going to use the knowledge of momentum to analyze it. Initial momentum equal to final momentum. For the initial momentum, this object, as they are moving, they moved opposite. So you're going to have M1, maybe U1, minus M2, U2. Although here, I use the formula directly, VCM, which is velocity of their center of mass. Velocity of their center of mass. That's the meaning of VCM. I'm analyzing question 45. And that's likely the last part we are going to deal with, because the other ones, I've covered them completely in part 1 and part 2, like I said. If you look at the formula I use for the velocity of the center of mass, some person might just like, this thing about center of mass, what is there? It's 1 plus 1. This is purely momentum problem. Just what we treated on conservation of linear momentum just now about collision. So initially the two objects are moving opposite. Mass of 2 kilogram and velocity of 3 meter per second. And then the second guy is mass of 3 kilogram and velocity of 2 meter per second. As they are moving in opposite direction, it's going to be m1 u1 minus m2 u2. Then equal to the final momentum, which if you want to m1, are you there? v1 plus m2 v2. You know, we're not told that they moved apart after collision. There was no statement like that. Whenever there is no statement in the final collision situation, under the final collision condition, if you are not told that they moved apart, you analyze it as inelastic collision, which means, okay, they collided and then they stuck together. Are you following, right? They moved with common velocity. It is a common velocity they're asking you to find here. The common velocity is the velocity of each center of mass. So you are using the same formula. You can see there's nothing to explain further there. That formula VCM equal to M1 V1 minus M2 V2 all over M1 plus M2 is simply obtained from M1 U1 minus M2 U2 equal to M1 plus M2 in brackets, then times the common velocity. That common velocity, you call it the center, the velocity of the center of mass. So that is that for that question. And then question number 46, still on center of mass. Still on center of what? Mass. In this case, the problem is on mass and distance. The problem is on mass and what? Distance. And now you can see the formula given there. The denominator is actually sum of masses. When you are dealing with center of mass, the denominator will come as sum of the masses. You can even see it in question number 45. The denominator is sum of the masses. Are you following, right? So that's just one of the key things you want to take note of. Question number 46, let me read it out and then you see what we have there. Consider the following mass distribution where x and y coordinates are given in meters. 5 kg at 0,0 meter, 3 kg at 0,4 meter, and 4 kg at 3,0 meter. Where should a fourth object of 8 kg be placed so that the center of mass of the fourth object, let me see. So now, can I get a video on momentum only? Yes, you can. You can. Go to the playlist still, but under, I think, in the homepage of this channel. Once you visit the GMAETS 41's channel, if you view the channel, you come to the homepage. On the homepage, just scroll gradually. You will see Physics 101. It has 6 parts. Part 1, I think, is it 6 or 5 parts? Part 1, Part 2, Part 3, Part 4, Part 5. You will see where momentum appeared. Are you getting me right? I think momentum should be in Part 3 or so, either Part 3 or 4. Part 3 or 4, thereabouts. You will see momentum video only there. You will see that. Okay, so let's continue. Where should fourth object of 8.0, that's where should the fourth object of 8 kilogram be placed so that the center of mass of the four object arrangement will be at 0,0 meter. Where should the fourth object of 8 kilogram be placed so that the center of mass of the four object arrangement will be at 0 meter? That is the question. So you see, The formula is there. All you just need to do, you use the x coordinate in the calculation and then use the y coordinate in the calculation. If you look at the values given to you, they give us the value of x and the value of y. Those distances given in brackets. The first one is 0, 0, so x value is 0, y value is 0. Those are distances. When you have the mass 3 kilograms, second mass, the position along the x-axis is 0, and then along the y-axis is 4. So you can see 0, 4. Then the mass of 4 kilogram, you can see the coordinate 3, 0. So the x value, the x distance is 3 and the y distance is 0. So with this information, they now ask us, where would you place a fourth object? Are you following, right? Whose mass is 8 kilograms, so that the center of mass of the 4 object arrangement will be at 0, 0. So they just want you to get the x and y value, where you will place the fourth object. That object of 8 kilogram, what will be the x distance from the origin? What will be the y distance from the origin? That is what they want you to get. So you can see the formula. If you want to calculate for x value of the fourth object, simply mass 1 times distance 1, m1 times x1, plus m2 times x2, plus m3 times x3, plus m4 times x4. Divide everything by the addition of all the masses, equates to 0. That's how you handle the case of center of mass for masses and distance. For masses and distance. But remember, the center of mass of the velocity in question 45, that one, you apply knowledge of momentum. This one, the formula you apply looks a bit alike, but what you are multiplying here is mass and distance, mass and distance. Then you divide by the sum of the masses and equate to 0. Equate to what? 0. So it's a straightforward formula. For that of x, you see, after solving that, x4 we don't know. We don't know where the position of the fourth object of 8 kilogram is meant to be placed along the x-axis from the origin. So it's going to be 5 times 0. Why do we have 0 in the first place? If you look at the mass of 5 kilogram, the x-coordinate is 0. That's why you multiply mass of 5 kilogram by distance of 0. Then plus m2 x2. m2 is 3 times x2. x2 is 0. Why is it 0? Go and locate 3 kilogram mass in the question. 3 kilogram mass, the distance coordinate is 0, 4. 0 is x-axis coordinate distance, and 4 is y-coordinate distance, y-axis coordinate distance. So the mass 3 was placed at the point 0 on the x-axis and at the point 4 meter on the y-axis. So since we are solving for the x-axis, m2 times x2 will be the mass m2, which is 3 kilogram times 0. 0 is the x2 value. Then you add to m3 x3. If you look at m3 x3, we have 4 times 3. The third mass is 4. Now the x coordinate, in fact, the distance coordinate was given as 3, 0 meters. So the first value is the x coordinate, the second value is the y coordinate. 3 is our x3, which is the distance of the third mass given as 4 kilogram. Its distance along the horizontal axis from the origin. So we know it to be 3. Therefore, it's going to be the mass, the third mass, which is 4 kilogram, times its horizontal distance, x-axis distance, which is 3. That is why we have 4 times 3. Then plus 8 kilogram mass, the mass whose position we are now looking for. So it's going to be 8 times x4. We don't know where you are going to place the fourth mass along the x-axis. We don't know. So that the center of mass will be 0, 0. So that the center of mass will be 0, 0. Now take note. You know, one question I feel that some of you might be asking is, why did we make this thing equal to 0? When we did m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 all over m1 plus m2 plus m3 plus m4, why did we equate it to 0? Because I must tell you this, there are cases it will not be equated to 0. And I'm going to expose this to you. In the question, we are asked, where should a fourth object of 8 kilogram be placed so that the center of mass of the 4 object arrangement will be at 0, 0. You see, your M1x1 plus M2x2 plus M3x3 plus M4x4 over M1 plus M2 plus M3 plus M4 is equal to the center of mass. It's actually supposed to be equal to x cm. That is equal to the distance of the center of mass. That left-hand side of the equation that I made equal to 0. By standard, it's not meant to be equal to 0. Why I made it equal to 0 is because we are told that the center of mass should be at 0, 0. That formula is meant to be equal to x, which is distance, then subscript cn, which is center of mass, read as the distance of the center of mass. Just like question number 45 that we read, we are told to calculate the velocity of the center of mass. This one, we are calculating the distance of the center of mass. And so when you work out that formula m1x1 plus m2x2 plus m3x3 plus m4x4 all over m1 plus m2 plus m3 plus m4, you are meant to make it equal to x cm. But what is the distance of the center of mass for this question? Along the x-axis, it is 0, because we are told that the center of mass of the 4 object arrangement should be at 0, 0. So that is the analysis of this question. With this, now it's just for you to simplify the mass there. 5 times 0 is 0, kick it off. 3 times 0 is 0, kick it off. 4 times 3 is 12, it will remain. Plus 8 times x4. You don't know x4, so it's going to be 12 plus 8x4. All over, add up all the masses. 5 plus 3 is 8. 8 plus 12 is 20. 20 plus 8 is 28. Are you following, right? So what you have in the numerator is 12 plus 8x4 all over 28. Everything equal to 0. If you cross multiply, 28 times 0 will give you 0. So 12 plus 8x4 equal to 0. Solve for x4, you get minus 1.5 meter. So the center of mass along the x-axis of the 4th object of mass, 8 kilogram, is meant to be placed on the negative axis of x, a distance 1.5 meter. That is the implication. Before we move on to explain where the x coordinate of the 4th mass is, where the y coordinate, rather, the y coordinate, the vertical coordinate of the 4th mass, before we move on to where it is meant to be, I'd like to say something. If we are told, or we are asked this question, where would the 8 kilogram mass be placed so that the center of mass of the 4 object arrangement will be at, and you are not told 0, 0. Let us assume you're told will be at 2, minus 4. 2, minus 4. That 2 is the x value of the center of mass. So that m1x1 plus m2x2 plus m3x3 plus m4x4 over m1 plus m2 plus m3 plus m4 will now be equal to 2. Because 2 is the x coordinate of the center of mass in that case. And then if you come to calculate for the y coordinate, m1y1 plus m2y2 plus m3y3 plus m4y4 over m1 plus m2 plus m3 plus m4 will now be equal to minus 4. Because minus 4 is the y coordinate of the center of mass. So remember, what you made that is m1 x1 plus m2 x all over the sum of the masses. What you make it equal to is simply the value of the coordinate of the center of mass. For this our question, the center of mass is said to be at 0, 0. That is why each of the left-hand side of the formula will be made equal to 0. If the center of mass has its own value, x, y value, which is not 0, please, that value, each of them is what you're going to use for each of the 2 case calculation. Let us move on to the second case now, where we are to calculate the point where mass 8, the 4th mass of 8 kilogram, is to be placed along the y-axis from the origin. Apply the same formula, nothing is there. m1y1 plus m2y2 plus m3y3 plus m4y4 all over the addition of the masses, the sum of the masses. Make it equal to the y coordinates, the y value of the center of mass. And for our question, it is equal to 0 still. You don't know y4, that's what you're calculating, right? The position of the 8 kilogram mass along the y-axis. Fix the value of the other guys. The values are already given, the distances along y-axis are given. For 5 kilogram, the y-axis distance is 0. So it's going to be 5 times 0. For 3 kilogram, the y-axis is 4. So it's going to be 3 times 4. You can see the substitution there, right? 3 times 4, which gave us 12. The first one, M1Y1, is 5 times 0, which is 0. The second one, M2Y2, is actually 3 times 4. 3, which is the mass, M2, and 4, which is the Y2 value, and gave us 12. Then the third mass is 4 kilogram multiplied by the Y value. The Y distance, the distance of that mass along the Y-axis is 0. Is 0, so it's going to be 4 times 0, which of course will give you 0 there. And then finally, the fourth object, 8 kilogram, multiplied by its distance, which you don't know, along the Y-axis, which is Y4. That is what I got there. The denominator is 28, equal to 0. Cross multiply, you get 8y4 equal to minus 12. If you cross multiply initially, 28 times 0 will give you 0. Then in the numerator, you have 12 plus 8y. So everything will be equal to 0. Solve for y, and you find out that y is minus 1.5, which means the fourth object, the fourth mass of 8 kilogram, will be placed on the negative axis, a distance 1.5 from the origin. That is how you handle center of mass problem. And honestly, we have come to the end of our part 3 revision. You see, this thing is, I actually went a bit deep again, summarizing the course outline entirely of Physics 101. It's just some other few topics, which, like I told you, go back to them in part 1 and part 2. I've taken my time to revise much of your works here in your manual. I have done that. These ones are also on center of mass. I following these ones on center of mass, question 47 and 48. You can go through that. After that, you have rotational dynamics. Now, this is what I want to tell you about rotational dynamics. I think in rotational dynamics, after circular motion, simple harmonic motion, rotational dynamics, I touched them as well too. I guess, is it part 2, if I'm not mistaken, or part 1? I think part 1, part 1, I guess, of the revision. So rotational dynamics is very simple. Please, do not learn rotational dynamics as if it is a different topic. Now lie. Rotational dynamics no be different topic. Rotational dynamics is fully dependent on everything we have done on linear motion, translational motion. Is the equation of motion v equal to u plus at, s equal to ut plus half at squared. You have square of v equal to square of u plus 2as. All of those equations, they still appear under rotational dynamics. The only thing you need to do, all the formulas from translational motion, many of them still appears in rotational dynamics. Know the definition of moment of inertia. The moment of inertia of an object is defined as the product of mass and the square of distance of transfer. Okorafor, you are welcome, man. Thank you for appreciating what I have done. I appreciate. So I'm just trying to give you a quick summary on rotational dynamics. We have finished your physics. Yes, we have. Rotational dynamics is not an independent topic. I'll give you an instance. Look at this question, number 49. Question number 49, right? Okay. Now, question number 49 is something you see under circular motion. Relationship between angular velocity and translational and the tangential velocity or linear velocity. V is equal to omega W. Take note of that question number 49. It is a cool exam question. It's an exam question. Are you following, right? Question 50. Question 50 is on conservation of energy equation. Are you following, right? If you have, I had said something under conservation of mechanical energy. If you come to rotational dynamics, we also have conservation of energy there. The only thing is that, remember, in rotational dynamics, the total energy in rotational dynamics is equal to the rotational kinetic energy, which is half I W square, where the I is moment of inertia, and then the W is angular velocity. Rotational kinetic energy is equal to 1/2 IW square. That guy is still similar. It's still very similar, 99% similar to the formula of kinetic energy you know. Normal kinetic energy, which we just simply pronounce kinetic energy, is half mv square. Now, rotational kinetic energy now is half IW square. They are similar. V square has been replaced with W square in rotational dynamics. Then mass in translational motion. Under dynamics, we're hearing mass. If you go to rotational dynamics, we replace mass with moment of inertia I. We replace mass with moment of inertia I. So pay attention as I state all these things for you. I'm going to be very fast. And then you have a special video that deals with what we call corollary. That is similarities, analogy between translational quantities and rotational quantities. Let's get to business. I am really at the point where I need to go and sleep now. So let's just be very fast. In translational motion, displacement, we use X for it, either letter X or letter S. In rotational dynamics, that guy changes to theta. We call it angular displacement. And the unit of angular displacement is radian. Are you following, right? Now you want to take note of this. Sometimes the angular displacement will be given in terms of cycle, or in terms of revolution, or in terms of oscillation. Take note that one cycle is equal to 2 pi. One revolution is equal to 2 pi. One oscillation is equal to 2 pi. And that 2 pi you are seeing is your theta value, is your angular displacement. So what I'm trying to say in essence is that if an object rotates once, turning one cycle, are you getting? One cycle is one revolution. It's also called one oscillation. The angular displacement value theta is equal to 2 pi. Are you following, right? So if you are given any number of oscillation, any number of cycle, just multiply by 2 pi, you get your angular displacement theta. So that aside, now you can see that angular displacement theta is not a new quantity. It's not. It's something you know from translational motion. What about velocity v? In translational motion, velocity is v. In rotational dynamics, velocity is angular velocity, omega, w. And that w, by standard, the direct formula is 2 pi r. 2 pi f. 2 pi f, 2 times pi times frequency. And f is 1 over period. So omega can still be written as 2 pi over period. That was the question we met, where I told you have to use centripetal force first to calculate velocity and then do one or two things as, are you following, right? So it's not something new. Now, we talk about the relationship between translational velocity and angular velocity. But before, I can talk about that now. Translational velocity v, which you meet in translational motion, is equal to radius times angular velocity w. That's the relationship between these two velocities, one from translational, the other one in rotational. Now let us talk about acceleration. In translational motion, acceleration, we use a for it, small letter a. In rotational dynamics, acceleration, we don't use a for it anymore. Rather, we use alpha. Now, what is the relationship between these two accelerations? We've encountered it in the course of this part 3 revision. Translational acceleration, small letter a, is equal to radius times angular acceleration alpha. Just like you saw in the case of v equal to rw. The same thing, a is equal to r alpha. So you take note of that, very important. Conversion from revolution per minute to radian per second. You can see how you do the conversion there. Under question 49, you have the conversion approach. If you want to convert anything given to you in revolution per minute to radian per second, all you just have to do is to multiply, if you're converting to radian per second, yeah, per second, not per minute, because most times they give you in radian per minute, you change to radian per second. All you need to do is to multiply by 2 pi. Assuming I give you an object moves at 20 RPM. That RPM means revolution per minute, 20 revolution per minute. That 10 is actually a unit for angular velocity, but it's not a main unit. It's not the main unit. So you have to convert that revolution per minute to radian per second. And to convert, you multiply like that 20 now by 2 pi and then divide by 60. That's how you change from RPM to radian per second. Okay. This question 49, I think in the question we are actually asked to calculate angular velocity in radian per minute. So when we solved in radian per second, you can see that omega is 32.3 radian per second. I now converted to radian per minute. Perhaps that's what the manual, required. Question 49, let me check. It says calculate the angular speed. A car with wheel of radius 43 centimeter. I repeat, a car with wheel of radius 43 centimeter moves at a linear speed of 50 km per hour. Calculate the angular speed of each wheel in radian per minute. So here we are asked to calculate in radian per minute. However, generally, what we do is to calculate in radian per second. If they give you something in radian per minute, you change it to radian per second. And I've told you how to convert to radian per second from revolution per minute rather. We are asked to calculate this in RPM, which is revolution per minute. But like I said, usually you convert even from revolution per minute to radian per second. Just that this particular question, the examiner insisted that we should get our answer in revolution per minute. So what I did is, do your normal solving. I converted the radius in centimeter to meter, and then the velocity in kilometer per hour to meter per second. The conversion factors are there. Apply the formula. Omega is V over W. Calculated it directly in its SI unit. SI unit of omega is radian per second. Then I now reconverted it to revolution per minute. Remember, I told you to change from revolution per minute to radian per second. You multiply that revolution per minute by 2 pi over 60. Now, to change from revolution per minute now to radian, to change from radian per second to revolution per minute, you do the opposite. So if I give you 20 radian per second to change to revolution per minute, you will multiply that 20 by 60 and divide by 2 pi. But like I said, in most general cases, what you are required to do is to calculate in radian per second, which means it would even give you angular velocity in revolution per minute while you change to radian per second by multiplying the revolution per minute by 2 pi and dividing by 60. All right, let's continue, please. I've given you the corollary between translational motion and rotational quantities. I've given you some of them. Now let us move on to the other ones. Under translational motion, we study equations of motion. V is equal to U plus AT. In rotational dynamics, that equation becomes omega 1, or let's say omega 2 for final angular velocity, equal to omega 1 for initial angular velocity plus alpha t. Because in translational motion, it is V. V will now be replaced with omega 2, which is final velocity, and then equal to U will be replaced with omega 1, which is initial angular velocity, and then plus AT in translational motion. In rotational dynamics, it will now become plus alpha t. To now become plus alpha t. The second equation of motion is S equal to ut plus half AT squared. In rotational dynamics, is going to be theta, because our S there is displacement or distance. Here in rotational dynamics is going to be theta equal to omega 1t. That omega 1 is initial velocity times time, and then plus 1 over 2, which is half. In translational motion, it is half AT squared in translational motion. In rotational dynamics, it's now going to be half alpha t squared. Third equation of motion, square root of V equal to square root of U plus 2as. Translational motion. In rotational dynamics, it changes to square of final angular momentum, which is omega 2 square equal to omega 1 square, then plus 2 alpha theta. Plus 2 alpha theta. No longer 2as. No longer as, but alpha theta, because a will be replaced with alpha and then s with theta. Okay, let me jump quickly to something. We talk about the concept of force. Force, we encounter it in translational quantities. In rotational dynamics, force is replaced with a quantity called torque. With a quantity called what? Torque. We use the symbol tau to represent it, Greek letter T. Now, in translational motion, we know that force is equal to mass times acceleration, Newton's second law of motion. In rotational dynamics, that force will now convert to torque. So F equal to ma. M in rotational dynamics is I, mass. From translational motion, if you go to rotational dynamics, it is moment of inertia I. And we have said that A in translational is alpha in rotational. So if F is equal to ma in translational, in rotational, torque, tau, will now be equal to I alpha. I for N, alpha for A. I hope you're following, right? Now, let me give you this one about momentum. Momentum is mass times velocity. Momentum is mass times velocity in translational motion. We use mv for it. In rotational dynamics, momentum, we use L to represent it, angular momentum. We use L. The formula will now be IW. IW. Look at the relationship now. In translational motion, momentum is mass times velocity. That is mv. mv, translational. In rotational, m will be replaced with I. V will be replaced with omega, which is W. So you now have L, which is angular momentum, equal to moment of inertia I, and then times W. There are still others of them that you should be aware of. Rotational dynamics video lesson teaches you all of those. Then remember, moment of inertia formula is mass times square of distance. Usually the distance, we use arrow for it. Chapter 11, all the questions in chapter 11, please take note of it. All the questions in chapter 11. All the questions in chapter 11, which are question 49, question 50, where you use conservation of energy, considering both translational energy and rotational energy there. Question 51, question 52, these are classical exam questions. Some of you will meet it in your exam. So you go through it, understand, what was done there. I've told you that the knowledge you use here is still the same as what you learned in translational motion. You can see formulas that are similar. See question number 51, calculate rotational kinetic energy. 1 over 2 IW square. I is similar to your mass. W is similar to your V. Then, for moment of inertia, I want to quickly highlight on that conclusively as we close. Moment of inertia is mr square, like I said. But please take note, each object has its own moment of inertia. Each object has its own moment of inertia. So you are expected to memorize the moment of inertia of different objects. For example, look at question number 51. The moment of inertia of a disk is not just mr square. Rather, it is mr square divided by 2, which is same as 1 over 2 mr square. I'll tell you, moment of inertia of a solid sphere. Moment of inertia of a solid sphere is 5 over 2. 5 divided by 2 mr square. So all these shapes, you are meant to memorize their moment of inertia. Before I show you a short note where you can go through and cram the moment of inertia of some object, because any one of them can be thrown at you, to say something about what we call the radius of gyration. Radius of gyration, we use capital letter K for it. It is the distance from the center of mass to the axis of rotation. Let me assume that this device is rotating around my finger like this. And let us assume that the center of mass of the object is here. Let's assume that the center of mass, where the total weight of the object is concentrated, let me say it is here. And like I said, the object is rotating about this point, about this axis. Are you getting me right? The radius of gyration is the distance from where the total mass of the object is concentrated. Where the total mass is called the center of mass. The distance from there to your axis of rotation, that is the distance from here to this point, is what we call the radius of gyration. Generally, moment of inertia I is equal to mass times the square of radius of gyration, which means radius of gyration is going to be square root of I, moment of inertia, divided by mass. So take note. Some of you will see exam questions on that. Are you following? Now, I told you something about force being equal to MA, and then in rotational dynamics, that force is replaced with torque, and it's equal to I, which replaces mass, moment of inertia, and then times alpha, which replaces acceleration. You can see question number 56. A crystal clear example of that. You are given the moment of inertia I of an object. If the moment of inertia value is not given to you directly and they mention the name of the object, you should know the formula that solves the moment of inertia in that case. You should know the formula. Let me boost this network, please. Sorry, I had to boost the network. So like I said, if the moment of inertia of an object is not given to you, if the value is not given, but you know the name of the object, look for the formula of the moment of inertia of that object and then use it to solve. Like for disk, look at question 53. For disk, the moment of inertia is half mr squared. Are you following right? So you take note of that. I've told you for sphere, the moment of inertia is 5 all over 2 mr squared. Okay. Question number 57. I am not seeing it as an exam question for you, so you may choose not to bother yourself about it. Question number 58. Question number 58. I'm not convinced. Question 59. Oh no, sorry please, I want to correct something. The moment of inertia of a solid sphere is not 5 over 2, rather it is 2 over 5. Moment of inertia of a solid sphere, a spherical object, okay, is 2 over 5. I interchanged it earlier. It's not 5 over 2. It is 2 over 5 mr squared, please. Question 57 has it for you to see. Okay, question 57 has it for you to see. So sorry for that initial misplacement. I mentioned 5 over 2 instead of 2 over 5. Don't worry though, I'm going to show you a short note, just one page note where you can cram some of those things. Question number 58. Okay, is a likely exam question. You simply use I1W1 equal to I2W2 to solve it. Okay, it's possible that some of you may see it. Yeah, but I'm not so convinced about question 58. Question 59, sure. Question 59, sure. Some of you will meet it. Now question 59, please, there is nothing new there. Let me read out that question 59. That question 59 is from the law of conservation of angular momentum. The way you know about the law of conservation of linear momentum, where we came up with the formula m1u1 plus m2u2 plus equal to m1 v1 plus m2 v2. If it's a case of inelastic collision, there's common velocity, so it's going to be m1 plus m2 bracket and then vc, common velocity. That is what you have in question 59. Question 59 is an application of the law of conservation of angular momentum. That question 59 reads, I'm going to read it out. I've told you question 57 is not realistic. You don't need to bother yourself about that. You won't see any question like that. You won't see that. Question 56. Question 56, did I talk about it? Okay, yes, it's an exam question. 54 is an exam question. Question 53 is also an exam question. So in chapter 12, question 53, question 54, 55, 56, they are all exam questions. 57 is not, you don't need that. 58 is an exam question. 59 is an exam question. So I was going to read out 59. Question 59, we have two wheels of moment of inertia, 4 kilogram square meter and 2 kilogram square meter, rotate at the rate of 120 revolution per minute and 240 revolution per minute respectively, and in the same direction. And in the same direction. So there will be no minus in this equation. Everything will be plus, plus, plus. If the two are coupled means they stuck together. Are you following, right? And that is why when we'll be talking about calculating common velocity, this is much like inelastic collision. If the two are coupled so as to rotate with a common angular velocity, find the speed of revolution. Find the speed of revolution. That is, find the final angular momentum. It's still the same. Sorry, find the final angular velocity. It's still the same as somebody telling you to calculate the final common velocity. Now look at the formula. You know, in translational motion, conservation of linear momentum, the overall formula is m1 u1 plus m2 u2, the initial total momentum. You know that in rotational dynamics, mass is replaced. Mass is analogous. Mass is analogous to moment of inertia I. So in that formula, you know m1 u1, change mass to I, change velocity to w. That is just it. The formulas are the same. So you can see the formula here. Let me bold in it. You can see it. We have IA WA1 plus IB WB1. Those are the initial values. And that is equal to, you sum their moment of inertia, just like doing m1 plus m2. You do IA plus IB in bracket, then multiply by the common velocity, the final velocity. If you do that and you solve, you are going to get what you have there as 2.67 revolution per second. Please take note of the conversion. Take note of the conversion in that question 59. The examiner asked you to calculate the angular speed of revolution. That is the speed of revolution. That's what we are asked to calculate, which means the angular velocity is given to us, which is 120 revolution per minute and 240 revolution per minute. We don't need to change the revolution to radian. We don't need to. What we just have to do is to change the minute to second, because our answer, the speed you're asked to calculate, is speed of revolution. So you calculate in revolution per second. You don't need to convert that revolution to radian. But assuming you were just asked to calculate the common angular velocity, and there is no mention of in the speed of revolution, just calculate the common angular velocity or the common angular speed. You have to convert that revolution per minute to radian per second. And I've told you how to do the conversion. Multiply that 120 and 240 given to us. In that case, if you are changing to radian per second, multiply by 2 pi and divide by 60. So that is it. The final thing here, question 60, is a crystal clear exam question. Take note. A crystal clear exam question, question 60. A man standing with outstretched arms on a frictionless rotating turntable has a mass 0.2 kilogram in each hand. The moment of inertia of the system in this position is 150 kilogram square meter. The unit of moment of inertia is kilogram square meter. Take note. He slowly folds his arms until the moment of inertia is reduced to 60 kilogram square meter. The angular velocity of the system is now 5 radian per second. Find the initial angular velocity and the new kinetic energy of the system. So that is the solution. Are you following? People that dance ballet, right? Ballerinas. Are you getting me? They apply this principle. Most times you see them, their arms will be stretched. They'll fold it in here. When you fold it in, what you do if you are spinning and your arm that is stretched, you want to conserve angular momentum. If you fold it in, what will happen is that, excuse me, let me save my device. If they fold in their arms, what will happen is that their moment of inertia will be reduced. Are you following? Imagine you are asked that somebody is spinning, and as the person is spinning, what will happen to conserve his angular momentum? For the angular momentum to be conserved, the person will withdraw his or her arms in. That means the person lowered the radius. So the person is going to reduce the radius. When the radius is reduced by folding in his arm, the moment of inertia will be reduced in that case. And when the moment of inertia is reduced, the speed, the angular velocity of the person will increase. I repeat, someone that is spinning, if the person wants to increase his speed, yet conserving his angular momentum, what will the person do? The person will fold in his arm. That means the person reduces the radius. The implication is that the moment of inertia of the person will reduce. And if the moment of inertia of the person reduces, the speed, which is angular velocity of the person, will increase. Take note of that. They have asked that question before. They have asked it. So I want to take note of it, okay? But if the person extends his arms, the moment of inertia will increase, and the speed, angular velocity, the rate of spin will reduce. This is where the GMAETS 41 draws the curtain for the revision. You know, it's been a very long one, but it's worth it. And I've told you, as my final address, your exam questions are very simple. Take notes. Your exam questions are there with you in your house now. It's there with you in your house. The answers to your exam questions, they are there with you in your house. As you follow through with all of the guidelines I gave you through this GMAETS 41's channel, those 2 other revision videos, very important. They are on platinum level. You need to support this channel on platinum level, just 2,000 naira monthly, and you get access to all of the materials, you know, for your revision. Remember, your Math 101 is still coming. I may not have the time to do anything further. The revision video lessons are already there. There is nothing they are setting different from the standards that is known for these exam questions. Your Chem 101 is still coming. The revision video is also there. Join the GMAETS 41 learning community. Become a channel member. You can join on the platinum level, which is 2,000 naira monthly, or you join on the diamond level, which is 4,000 naira monthly. This is a way of supporting this channel, supporting what GMAETS 41 is doing to give you the very best. Like I said, do not be scared. Be confident. Your exam question is not coming from heaven. It's not. It's within what they've taught you. The only thing is that, okay, you might think that they did not teach you well, whatever. I am not interfering. The choice is yours. The decision is yours. You were the one that attended the lecture. You know how you experienced your lectures. Whatever the case is, I don't care about all of those things. The lecturers are doing their own doings. GMAETS 41 is doing his own doings. And for one thing, I know for sure 100%, there is nothing, I repeat, no single thing that you have been taught or you would even be taught that are not covered by GMAETS 41 on this channel. Like I said, your exam questions, they're a replica of everything covered on this channel. I wish you all the very best. You want to be confident. You want to be confident. Your exam questions are 1 + 1. If you have done the needful, following especially the instruction I've given to you, go in there and get the GMAETS 41. Your A splashes. I wish you success, and I know that you're going to make yourself and GMAETS 41 proud. This is GMAETS 41. Good night, and I wish you the very best once again.